Hola, pero se te mueven las lucecitas. Sí, va. eh,
Sí, hola. Probando. Uno, dos, tres. Hola. Probando, probando. Sí. Hola.
My name is Jose Cantera. I'm not Juanjo Hierro. Juanjo Hierro is not a, well, I'm with Telefónica. I'm part of the FIWARE team. I've been working with FIWARE around 1 year and a half. And well, today I'm going to start this session on the technical aspects of FIWARE, given guided by FIWARE, and some success stories, an overview of the communication and this event, the first FIWARE Summit. Well, if I can see many people new here and that I have not met before, and probably you would like to know. All of you probably are very familiar with one is big data, another is Internet of Things. Well, cloud computing is something that has been around for many years. And all of you probably are here. Is starting to be called by the industry as smart applications. So, but we need to think about if we want to create a smart application that is IoT enabled. So that smart application is exploiting the data, real-time data coming from the Internet of Things, and then is capable of analyze this data in the big data analytics, etc. So we need a very important aspect for being smart, which is being context aware, okay? So being context aware is something that is very well explained by this picture, because this guy is in the middle of a day, a rainy day. He's trying to clean the vehicle. He's trying to clean the car. And well, this makes no sense. On one hand, it makes no sense start cleaning your car in the middle of the rain, but it is not very smart to clean your car if it is raining, because the car is cleaning itself. So that is a very well explanation of what means smart. So for being smart, the necessary condition is, but not sufficient, but a necessary condition is to be context aware. And one of the key components that provides FIWARE, that is being provided by FIWARE, is a component that allows you to model the context of your application, to model of the data that your application is going to need in order to be smart. So it's an important thing that context matters. So the context is any kind of data. So the context in this room is that we are in the FIWARE Summit, that we have certain illuminance levels, that there is a room with 100 people. All this information is going to allow you to create applications that are going to perform a smart behavior. And in which areas context-aware applications and smart applications can perform very well. So one of the key domains is smart city. So FIWARE has been working with the smart city domain for many years. And in the smart city, an important aspect is what is happening in the city here and now. So we can have context information about buses. So where are the buses? How many passengers? Who is the driver? We can have information about shops, about the citizens themselves. We can have information about parkings. We can have information about the traffic flows, about the air quality. All this context information FIWARE provides the components that allow you to model this context information, and all a catalog of data models that allow you to describe all this kind of stuff. Second interesting domain for FIWARE is smart agriculture, or smart agri-food, which is called as well. So in smart agriculture, there are many real-time data that you would like to know. So what is the humidity in a certain area? What is the location of a tractor? What is if a drone is performing some kind of analysis over the area? All this data can be used as well to create smart applications in the smart agri-food domain. So one application that is, I would say, the most important is what is called precision agriculture. So it's how to manage your crops using this real-time data or even historical data in order, for instance, to save pesticides, to save the amounts of pesticides, or even to save water. So if you don't need to water your crop, then it makes no sense. It's similar than the example that we put before with the guy trying to clean his car if it is raining. So this is the same. So if we can monitor the humidity of a crop, we can decide when this crop has to be watered or not. But of course, and the last domain in which FIWARE has a good position to enter is a smart industry. So in the smart industry, we have gas tanks, we have trucks that transport the gas, we have the stations. So we have many different entities that can be monitored and can provide context data that allows to create smart applications. So these are the three domains in which smart applications and the usage of FIWARE can perform very well. So we have identified several domains for smart applications on which IoT-enabled big data can play an important role and can be paramount. But what FIWARE can provide, because if you think about these domains, you can think, well, I have an application that solves this problem. I have another application. I know many applications that are already dealing with these problems and are solving the problems. But what FIWARE provides is two important aspects. One is a standard API for getting access to this context information. So FIWARE provides the components that allow you to monitor, to use this data and to offer this context data to the applications using a standard API. But not only that, it offers some harmonized data models that allow you to model the important entities in your application. For instance, if you are creating a smart parking application in a smart city, you have two options. You build your own data models, but when you go to another city, probably the solution chosen by the city will be different. And then as a result, you use the data in the different cities cannot do that because the data is offered using different APIs, using these standardized data models that allow you to model the data you need. And where this data comes from? This data comes from the Internet of Things available. For instance, the weather forecasts that the meteorological bureaus provide, these weather forecasts are not coming from an IoT device, are coming from the weather agency. But in the next talk, we will explain how this information is stored. And well, if we have these two very important elements, so harmonized APIs and harmonized data models, then we can build applications like this. So this is an application that we presented during the Mobile World Congress this year. And the idea is that having a smarter car navigator. So you are very familiar with car. It relies 90% on static data. So it is not very common to exploit real-time data. Well, you can see. So our car navigators nowadays cannot deal with real-time parking information, okay? And this car navigator that we presented has two characteristics. It can deal with parking information, so it can guide you to the closest parking to your final destination, and it can know the parking occupancy levels real time. But if you create a smart parking solutions which is closed and only expose a proprietary API, and that API is different than the API in another city and different in another city, and in every city is different, you cannot build this kind of application, because this kind of application is capable of exploiting parking data information exposed through the FIWARE APIs. So every city that exposes parking information through the FIWARE APIs and data models can benefit from this car navigator. So when you arrive in the city, you can discover that there is a FIWARE endpoint, and then automatically your car navigator can discover the parking information data, the real-time parking information data, and guide you to a suitable parking. So this is an example we did with the city of Porto and the city of Santander, and what is more important as well is, as FIWARE is independent, the context information in FIWARE is independent of the source, the car navigation application is not aware of where the information is coming from. So the information may come from the parameters, may come from sensors, ground sensors, may come from cameras. We don't know where it's coming from. The data to display properly and to perform the algorithms to guide you to the closest parking. So FIWARE provides a component which is called the Orion Context Broker component, open source component, because as you know, all the software in FIWARE is provided as open source. Our motto is open APIs for open minds. So FIWARE APIs are first of all open, so you can use to build your own implementations, but at the same time FIWARE provides reference implementation of these APIs. So the reference implementation of the component that is capable to manage this context information is called Orion Context Broker, and will be the next talk after this one, in which you will learn the details of these APIs for provisioning and consuming and subscribing to context information. And well, if we have this, and we have the capability of offer standardized context information, we can not only benefit the end users having more interesting application like this car navigator, which is smart and I can exploit the smart city information, but in the end, the entrepreneurs, the developers, and we have many of them here in this summit, and you create an application. If that application is based on the FIWARE data models and the FIWARE APIs, that application can be exported to many different cities, to the cities that are adopting FIWARE as the standard. When you start your investment, you can think that the amount of cities and the amount of potential customers is going to be bigger if you are using FIWARE to innovate. So providing this context information is enabling, for instance, provider, you can offer your data using the FIWARE APIs, but you can, why not, offer a service for that data. So you can make that data provision a payment service, a paid service, okay? So FIWARE allows you to, with a component which is called the business framework, to offer this data and to get money from offering this data. And this is something that will be explained today as well in a session by our colleagues. Another important aspect in FIWARE that you need to understand is that FIWARE isolates, so the FIWARE components allows you to connect your IoT devices using the typical IoT protocols. So you can deal with MQTT, you can deal with CoAP like WebM2M. So all the transports, typical transport in the IoT arena, you can connect your devices to FIWARE. But the important thing is that using the context broker, which is Orion Context Broker, the context management, you have an API, and if you're a developer, you don't need to know what is happening behind the scenes in the IoT world. So if you want, for instance, to know what is the power state of a lamppost in the street, you basically need to do a GET HTTP request asking for a particular attribute using the FIWARE data model. So this is very powerful, okay? Because allows you to create the application that controls your IoT devices or controls your city very, very easily. And furthermore, switch on a lamppost. You basically do a put request over the value attribute and you say power state on, and you are switching on the street light. So the context management layer allows you not only to read the data coming from the IoT devices or from other, of course, behind the scenes, and here we will show in the IoT session how this will work behind the scenes, because of course, your device is going to need to receive a command coming from which are in charge of dealing with your IoT devices and speaking the FIWARE APIs to the context broker. So in the southbound interfaces, you have your IoT devices, you have your IoT protocols, but in the northbound interfaces, you see a context management layer, and you actuate over the devices through the context management layer, okay? And we think this is a very powerful approach, and during these sessions today, I think you will love this approach. Well, and this new generation of smart applications, mainly in the and oriented in 3 domains: smart cities, smart agriculture, smart industry. I have been talking here about the 5. So around this context broker, you can set up, for instance, historical interfaces, short-term interfaces, IoT world, and you want to move that data, that historical data, to big data repository, and there perform analytics or all that kind of stuff, you can do that. There are different components that are, so here they are, some of them described. So we have as well a complex event processing technology. So complex event processing is something like the way to create new data from the arriving data. So you can create you can aggregate data through the complex event processing. You can create new kind of entities from the more simple entities, etc. We have components for multimedia processing. So dealing with context information sometimes means that you need to analyze images coming, for instance, from a camera to detect certain patterns of certain events. FIWARE provides a component called Currento to do that. FIWARE as well allows you through the CCAN. CCAN is one of the components being part of the community to publish open data. So if your real-time data, you want to publish some history of what has been happening in the real time through CCAN, you can do that. Or there is a component called Spago BI that allows you to do all the visualizations, advanced data visualizations. Even some of our colleagues today will explain some 3D and AR capabilities offered by other components. So you will see here that that in FIWARE there are different areas of work, different components. This is a big open source community and a big initiative. So FIWARE is structured around chapters. So here you will see that today we have meetings of different chapters. So one of the chapters is IoT, another chapter is data, Another chapter is apps. Another chapter is data, apps. We have the advanced UI, where all this augmented reality stuff is doing, etc. So the different projects in FIWARE, this is open source community, are structured around chapters, and the different chapters are dealing with different problems. And well, this is more or less an overview that I've been trying to explain to you of FIWARE and the FIWARE components, the FIWARE technology. But I would like to show some examples of applications already in the market, or very close to be in the market, that are already exploiting the FIWARE technology to create what we think compelling use cases. So one of them is in Silo. I think they will be exhibiting here. So the idea of in Silo is using 3D cameras for monitoring your silos, the silos in the farms. So instead of one guy going to the silo and making an inspection, a visual inspection of the level of the silo, you have a camera on top of the silo, and you are able, using this 3D camera and knowing the parameters of the silo, to know what is the current level in the silo. Because if you have a real-time data about the levels in the silos, you can, for instance, connect to the logistics provider and say, please, in 2 days, come with new material for the silo, because the silo in 2 days will be empty. So we need the material in 2 days. So this is an example of exhibiting smart behavior, because you are able to predict, using the real-time data information coming from the Internet of Things and provided through FIWARE, to decide when you are going to need more material for the silo. And as a result, you can save money, you can optimize your processes, etc., etc. That's the example of being context aware, because here the context information is the silo level in order to exhibit the smart behavior. Another example that can be shown today here as well is Vita. So here is the usage of FIWARE to create a multi-protocol gateway for homes intended to monitor energy consumption. So here the idea is that if you have a gateway which is capable of speak multiple protocols, so the different Zigbee, the different in the smart home, the different technologies in the smart home, even NB-IoT, which is going to be the next buzzword in IoT. So you are capable of dealing with multiple protocols. You can connect different devices, and particularly you can connect your energy consumption monitoring devices, and then you can optimize your energy consumption at home. So this is an important example as well of to use context-aware information, to use context information to perform a smart behavior. Well, with a device, it's a local company here in Andalusia. We've been working for many years, and we've been working in water management stuff. We have worked as well in a harmonized data model for water quality observed. So, for instance, in the city of Seville, there are some sensors in the Guadalquivir River that allows us to know different parameters about the water quality there, turbidity, conductivity, all that kind of stuff is exposed through FIWARE. And more importantly is that we have harmonized the data model for water quality observed. So if you have, you intend to create another application which is monitoring water quality, you can do it using our data model, or you can extend our data model, because it's something that can be done. Another use case we presented in the IoT Solutions World Congress, this is Fisonic. This is kind of 3D sound monitoring that allows you for instance, to detect certain patterns in the sound, in the noise levels. For instance, if there is a bomb or something similar to what can be an explosion, and you can detect that and generate an alarm, for instance. So it's a way of, it's not the typical noise monitoring that you can find, the traditional, but some kind of a smart sound noise monitoring that would allow you to detect certain emergency patterns, for instance, and will allow you to perform a smarter behavior. We have cardio ID. This is something I like very much, this idea, because the idea is that if you are able to put some kind of IoT sensible, IoT sensitive steering wheel, you are able to detect the the ECG signal of the driver, and you can detect certain patterns that allow you to detect, for instance, if the driver falls asleep. That's important in public transport, because if a driver is driving many hours between, for instance, in a road trip through 2 different very remote cities, and it lasts 6 hours, maybe the driver at some point in time could fall asleep. So you can detect that kind of events through the ECG signal. So this is a nice application of being context aware and reacting to that. And also it can be used, as the ECG signal is different from one person to another person, it can be used as well to detect that the driver change is done properly. As you know, the law mandates that driver change has to be made every 8 hours or 6 hours or whatever, depends on the country. And that can be used to monitor that action is performed, actually, because the ECG signal should have changed. And this one, I love this this showcase particularly because it was part of the Mobile World Congress this year, and we were in the news, in the TV news and the BBC, in the Spanish TV, about monitoring cattle which is outside, and the idea is that you use collars that are put on, moving through the temperature of the animal, and well, you can say, well, what's the purpose? Well, because many animals are 2 or 3 days, and you need to allow the farmer to monitor if you don't need to go to the place every day. But moreover, if you can know in advance that one of your animals is smart behavior as well, and is allowing you to save money and to be more sustainable, because you reduce the number, you are having less cost to manage your farm. This is something that the collars are successfully. So these are all the examples that I would like today to show. There are more in the exhibition area. I invite you to watch them, because they are nice, and you learn very much from these entrepreneurs have been doing with FIWARE. Well, if we are being talking people that or organizations that have been adopting FIWARE and the FIWARE APIs, and that demonstrate that you are on the good track for being a real standard. Well, first of all, 2 years ago, the Open and Agile Smart Cities initiative was launched. We have now 89 cities in 19 countries, and this Open and Agile Smart Cities initiative is basically means that these cities are intending to use FIWARE as their standard for managing context information in their smart city projects, using the harmonized data models, using the FIWARE APIs. We have been working and this has been consolidated this year with the GSMA in a project which is called IoT-enabled big data ecosystems. And GSMA has chosen the FIWARE NGSI version 2 API. NGSI version 2 is the API for context management that will be explained in the next talk, as a harmonized API for IoT big data enabled ecosystems. We have been working here not only in Telefonica, but we have been working here with Orange, with Chinese operators, with Korean operators, in defining, in developing this project that has adopted the FIWARE NGSI as the basis for providing real-time context information. We have collaboration as well with the TMF Forum and with NIST, which is the National Standards Institute in the USA, for having FIWARE in their smart city projects and the FIWARE APIs. So this is an example of the traction that FIWARE is getting in the moment. And we are very happy that external organizations, important industry associations like GSMA, TMF Forum, or even the USA Standards Institute is considering FIWARE. That's, I think, a sign that we are improving and doing well. I don't know why. Maybe this is... Can you do it manually? Yeah, thank you. Because this stopped working. Well, the next part of the presentation is that FIWARE is not only technology. So we are here because this is not only technology. So FIWARE is now a community, not only of open source developers, not only is technology behind, there's a community of entrepreneurs and a community of people creating solutions with FIWARE and benefiting from this ecosystem. The ecosystem is the technology plus the entrepreneurs. And this is starting to work very well. Yeah, thank you. Because in the end, what we pursue is to have an open innovation ecosystem. So we have FIWARE Mundus initiative, which is trying to extend FIWARE to other parts of the world. We have the FIWARE iHubs. The iHubs are the local, I would say, authorities in each country that are, I would say, giving the word about FIWARE. So they are the evangelists, local evangelists of FIWARE. We have the FIWARE Lab. We will have today a presentation on the FIWARE Lab. We have the FIWARE Acceleration Program. It ran with 80 million euros last 2 years, and now there is going to be another acceleration program of around 5 million. So this is accelerator, project accelerators, as many of them exist today in the world. But the difference is that the solutions has to be based on FIWARE. As a result, they are going to benefit from this community, and they are going to benefit from the existing market FIWARE is opening. So these smart cities, 90 cities, these smart agricultural projects we already have, etc., are a potential market for the companies and the startups that result from this acceleration program. And now our baby, the FIWARE Foundation, recently created. I think the final signature was November or October, I don't remember. Is going to be, the headquarters are going to be in Berlin. And the 4 founding members are Telefonica, Orange, Atos, and engineering. And now everybody can join the FIWARE community, the FIWARE Foundation. For instance, as an individual member, you can join, and it's free. The companies have to pay. Well, depends on the kind of the kind of membership. We have different kinds of membership. You can visit the page of the foundation and see what are the different options. But the most important thing is not that, is what is the mission of the foundation. So I think the FIWARE Foundation, the main mission is to keep FIWARE open and open source, to extend the usage of FIWARE, so that the ambition of the foundation should be that many projects and smart solutions start using FIWARE. And FIWARE consolidates as the standard, the open source standard for the IoT-enabled smart applications. This is our main ambition. And of course, allowing the community to grow. And another important aspect, from my point of view, is that what FIWARE creates is useful for the developers. And we get traction not only in big smart city projects or but also in smaller developers, independent developers, that FIWARE is their first options when they create IoT stuff, IoT-enabled stuff, or context-aware smart applications. That's I think, the main mission that the FIWARE Foundation has to achieve, and that will be a challenge for the next years. But I think we come with the help of all of you. And this FIWARE Summit is where we are today. I have had the opportunity to give the first talk. Well, this is the end. This is the end. Now I'm open to questions. You have to take into account this is an overview talk, so we will enter into the details today. Today and tomorrow and the day after, we will have deeper technical talks. So I would like you understand it's important if you are on how the things are done using our technology, and that will allow you to decide whether it is going to be. Now I'm open to questions. FIWARE Accelerator. As far as I know, there are names of the, I don't have the details, but this is going to be run as the previous acceleration program. So the EC provides the money to a couple of companies, and they are going to do the open calls and all the stuff, all the managing stuff of the acceleration program. Yeah? What is the process for cities to join FIWARE? Well, I think the main instrument is the Open and Agile Smart Cities Initiative. So this is a very nice way to do so. The thing to be taken into account is that for creating an Open and Agile Smart Cities branch in your country, you need at least 2 cities in your country. If there is an already OSC branch in your country, you only join the OSC. So this is, I would say, the way to say, well, I intend to be compatible with FIWARE in my city, but I think another nice way of starting working with FIWARE is, if you plan to do some smart city pilot, initial pilot, etc., talk to us, because we can help you in building it, and start using FIWARE in your city. So if you have already deployed IoT devices, we can connect them to FIWARE and create applications using this data, for instance. So depends. But if you want to officially say, I'm going to be FIWARE compatible, the best way is through the OSC Alliance Initiative for Cities. There are no more questions. Next session that you should not miss is Orion Contest Broker and the Contest Management APIs. Thank you very much for your attention.
Okay, good morning. My name is Fermín Galán. I am technological expert of Telefónica, and my role in FIWARE is the Orion Contest Broker Development Leader. I'm on chair of the component that provides contest management in FIWARE. This presentation covers three topics. First is contest management in FIWARE, although Jose has already done a very good introduction to the topic, so probably I will be quickly in it, given that I don't have too much time. Third aspect is Orion Contest Broker, which is the component, the software component that provides that API. So, contest information, as Jose has introduced, is a need for doing a smart application, and it's about the information or the data that your application will need. So, if you have an application, for example, in the smart city domain, the information regarding, for example, traffic, people, location in the cities, that information will constitute the context or your application. And another important aspect in FIWARE, or in the way FIWARE defines contest management, is the model of context we use. Our context is based in entities and attributes. Entities are things of the physical world or the virtual world, like, for example, a bus, a citizen, a shop, a table, a mobile, whatever your application needs to work. Those entities will depend on your application. Although, as part of FIWARE 4, we have defined a kind of standard entities and a standard model for that, the harmonized model that Jose has already mentioned. But from an agnostic perspective, your entities add whatever you need for your application to work. And those entities has attributes. Attributes are characteristics of those entities. For example, in the case of a bus, it can be the location of the bus, the number of passengers that the bus is currently carrying, the driver, the license plate, and whatever. And, well, the same for other kind of entities, like citizen, like a shop, or, well, other entities that your application may need to work, other entities that conforms the context of your application. This is another example, but it's basically the same. The previous one was based on a smart city domain. This one is based more, let's say, in the smart home domain. In your smart home, you can have entities that models your boiler, that models your plants, that model the light of your house, or whatever. And basically, context management is about well, it's redundant, but it's about managing the information on context. It's about creating these entities, creating these attributes, getting their values, getting the data, publishing the data, and getting in different ways, or with different approach. Another important aspect in context management is the independence between the actors that generate context and the actors that consume context. They can be completely different organizations, they can be completely different applications. For example, in the case of a city, you can have a producer of contests, sensors in the city streets, and provided by the municipality, the city itself, that are publishing that information. And on the other side, you can have applications developed by individual parties that are the ones that consume that information about the transport, about the traffic, and so on, to create a nice tool, nice application based on that. But the people of the organization in charge of context producer could be not the same that the one that is in charge of context consumers. So we have a kind of two roles: the producer and the consumer. And this is important, as we will see in the different operations that we will show next when we start looking to the API. Okay. Context management integrates pretty well with existing systems. So the idea is that you can have IT systems in general that are implemented in whichever way, that in order to be context aware, only needs to implement the API part that allows to communicate with the broker that is in charge of doing this management. Okay, we used to talk about context management in FIWARE as the SMAP of IoT. Do you know SMAP, the Simple Network Management Protocol? It's pretty old, but the principle behind it are still valid. So the idea is that you have primitives to get, in this case, network information. In the case of SNAP, in the case of context management, you will have operation to get context, and you have also ways of acting on devices. In the case of context management, you have ways of acting on your entities and make them to do some actions. So, for example, in this case, we have a lamp. The lamp status of the lamp, if on or off, can be retrieved. It's a get operation. But also, using the context management API, you also will be able to turn on or off the light. The idea is that you will update the attribute of the lamp, and this update has the effect of turning on or off the device. This is a similar example, in this case of a plant, a flower plant, and an actuator that give water to the plant or not, but it's essentially the same. And well, finally, the name of this API. I have been talking about the context management API all the time, but well, this nickname, this NGSI acronym, is the name that we give to the context management API in FIWARE. The name comes after well, a standard in the OMA, in the Open Mobile Alliance, in which we have inspired. At the end, the standard have evolved pretty far away of this, but we have keep the main ideas, the idea of entities, attributes, and the idea of how to manage that model comes from NGSI. But at the end, we have improved and created a more powerful standard that was originally at OMA. Okay, so this concludes this introduction about context management in FIWARE from a general or high-level perspective. So now let's start to see the details on how this implemented in FIWARE. I mean, the things you as developer needs to know in order to implement a context-aware application based on FIWARE. So basically, all is about this model, the entity and attribute model that I have previously introduced. So we have entities. Entities model things in the real or virtual world, like a citizen, a bus, a road, whatever. And entities are characterized by an entity ID and an entity type. So you have an ID, it can be a number, it can be an unique identifier, and a type. Type allows you to establish categories of entities. For example, you can have a category for the cars, a category for the mobiles, a category for a citizen. You can have a set of entities, all them belonging to the same type. And this is all useful in some kind of operation in the API. So each entity can have 1 to n, from 0 to whatever. 0 probably doesn't make too much sense, but it's possible from a formal point of view. But, well, you will have a set of attributes associated to each entities. And attributes are characterized by a name, a type, and a value. So, and those are, well, the description of the entity in some way. An important point to mention is that even different entities in the same time doesn't necessarily have the same attributes. So you can have one car with some attributes and another car with other attributes. So the model is pretty flexible. In this case, it's like in NoSQL database that you don't have a schema behind the different kind of entities. Okay, regarding the API to manage these contests, because at the end, the API, you will see that are different operations that manipulate in some way or another this construct is an API which is based in REST. It's a RESTful API. It uses HTTP as transport layer, and it uses JSON as encoding mechanism. In the past, we used XML also, but given that XML was not, developers doesn't like XML pretty much in the current days, we at the end remove XML, and this is no longer supported. The API has two big areas. One is for context management itself, that is about creating, retrieving, and updating this information. And also another part, which is quite more, let's say, is more advanced, which is about context management availability. Context availability management. That is about not of the entities and attributes itself, but the providers of those information. This may sound a little bit complex, but it will be explained during the talk. Okay. Just to mention that there are currently two versions of the standard. Two versions of the API. We started years ago with a first version that we call, as you may imagine, version 1, which is identifies in the URLs of the REST operation like by the /v1 prefix. But we start using this API by large much better. It has been improved, it has been simplified, and are based in version 2. For those of you that knows version 1, because you have been working with FIWARE and explain why, with a specific in each specific topic, version 2 is much better than version 1. So it's very, I think, it's in the agenda. Okay, so when to use, well, this is when to use NGS2 and NGS1. So the short answer, which circumstance you should use version 1? There are two cases. One case is to use functionality not yet covered in version 2. Version 2 is not finalized. Version 2 keep evolving. We have an stable release candidate, but there are areas that has not been yet covered by version 2, like context availability management. So if you need context availability management, you will need to use version 1. The other reason could be if your application has zero tolerance to change. If your application is, for example, in a satellite, and you can access to the satellite and reinstall your application, then you should use version 1, because version 2 is not, there could be some slight change in version 2 that will need to change your application. But during the development of version 2, we are trying to keep this change to the minimum, and from a practical point of view, it's not being a problem, this kind of slight changes. So as a summary, I recommend you to use version 2 in your applications. Okay, so how is this API implemented? How this API based on entities, RESTful, using JSON is implemented? It's implemented by a component or a generic enabler in FIWARE terms that is called context management, which nickname is Orion. So when I say Orion, I'm referring to context broker and the other way around. And this component is like another HTTP server. It's not very different from, for example, Apache, in the sense that it exposes a port, a service port for the API. This port used to be by default as 1026, although you can change using configurable parameters. And in this port, you will have two kind of actors access into it. Which actors? The one that I have mentioned in the introductory part of the presentation. You have producer of context that will be doing operation to create context or to update existing context, and on the other hand, you will have consumers doing queries to the context broker to get context. A part of this serving aspect, I mean, a part of exposing and a part in which the broker implements the API and receives the different REST operation, context broker is also able to send notification. Because there are two approaches to consume information. This one synchronous approach, in which the consumer goes to the broker, send a query and get the results in the response. And there is another mechanism based on subscriptions. This mechanism works in the following way. The consumer creates a subscription, programs a subscription in the broker, and when some condition occurs, the context broker sends a notification. And the consumer can get the notification in any moment asynchronously. Finally, you will see this component, a database. Context broker is able to persist information in the sense that when you create an entity or you update an entity, this value is at the end stored in a database. So if the broker is stopped or the machine, the host in which is running crashes, then that information will present in the database. This database is like a photo. It's like a snapshot of the context of your application. I mean, if you update an attribute, the previous value is not stored in the database. It's overridden. That doesn't mean that FIWARE doesn't support historical or temporal context information storage. This is done using other components. There is a specific talk about it. I think that is tomorrow, about Cygnus. Paco? It's tomorrow your talk, right? In this talk, my colleague Paco will explain how the context information that Orion stores can be persisted in different storage backends, like CCAM, MySQL, Mongo, Carto, and many others. But not today, tomorrow. Okay, so let's start playing a little bit with the broker. Let's start looking to, in the low level, how those operations look like. Are you familiar with REST? How many of you are familiar with REST APIs? Okay. How many of you are familiar with JSON? Okay, perfect. So I think that the most of you will can be follow this presentation without problem. Okay, this operation is not a real operation of the API. It's a status check. This operation, you has started to work with Orion and want to see if Orion has been properly installed or is working properly. This is the first operation you should run. This operation is just a confirmation that the server is up and running. So, because many times the problem is the API is not working or whatever, and the problem is that Orion is not working, or there is some kind of network connection, or the firewall has not opened the port that Orion is using, or whatever. So this operation will ensure that unless you are able to access to the API and you are able to execute the different operations that we'll see following on it. Okay, I have told that it's a REST-based API. So in REST, a fundamental concept are the resource, because at the end REST, most of the time is implemented with a verb, HTTP verb, operating in a resource, in a URL that identifies the resource. So in this case, we have two kinds of resource, entities and attributes. So we will have two kind of resource URLs. The slide shows the one used for the entities. So an entity is identified by this kind of URL, between the entity's constant token and the ID of the entity. And you have operation to get entities, to update entities. There are different flavors, slightly different. I will not provide too much detail today on this, but it's in the documentation. Also, we have an operation to delete the entities. And we have this operation to create a new entity. The usual pattern in REST is to do a post on the root URL of the resource. So this is what we are using right now. And also we have an operation to list the entities, which allows, as we see, different kind of filtering to filter that list and not get all the entities. That can be a very large set. Okay, those were the URLs for the entities, we have similar ones for the attributes. In the case of attribute, you will see that is a sub-resource of the entity. And makes sense because, as we've seen before, each attribute belongs to a given entity. So the URL is built with the prefix of the resource URL of the entity, and we add the attrs constant and the name of the attribute. So this provides the identification of a given attribute within a given entity. And the same, we have operation to get the attribute, update the attribute, delete, get the value. This is a kind of a specialization of the resource. This is the sub-resource value of the attribute, so we can directly access to the value if you want to get type. And the same for updating the value directly. But this is a kind of advanced stuff. Those are the basic ones. Okay. Let's see this with real examples. And for those examples, let's consider this very simple application. We have an application that is about cars and is about measuring the speed of the car. So on one side, we have in the car a context producer that will be the software within the car that will publish the speed of the car from time to time. And on the other side, we have an application. It can be in a web browser or in a mobile that get that information and does whatever we did. For example, drawing in a chart of calculating average or whatever. So this is our application, the producer and the consumer. So the first operation that you will typically use when you just have a start Orion and your context base is empty is to create something, to create an entity. And that is the operation to create an entity. So what do you need to create an entity? But to create an entity, you will do the operation on the entity's root, entity's prefix. And in the payload, using JSON, you will specify the parameters that define an entity, that are the ID of the entity, the type of the entity, and the different attributes. In this case, to keep things simple, we have just used one attribute, the attribute speed. But we can add whatever number, whichever number to just after this one. But in this case, we have the entity car1 of type car with a speed, and the speed and any other attribute is defined by a type. This case float. This is a free word. You can use whichever type makes sense for your application. Orion doesn't provide any semantic to this, except some cases for dates and for geolocation information. But apart from that, you can use whatever word. And the value. The value is, well, in this case, the speed of the car, 98 kilometers per hour. You can use any JSON type. You can use numbers. You can use booleans. You can use strings. You can use another JSON or another vector of elements, whichever that is support in JSON in general. So that is operation, and upon execution of this operation, context broker will create these entities with that attribute and that value. The response that context broker gives to the client is this one. It's just okay. Everything is okay. If some problem occurs, then you will get another kind of code. But in the case of correct operation, following REST principle and HTTP principle, you will get a 200 code. In this case, 201. Okay, so that operation is for creating an entity. This is another basic operation that once the entity and the attribute are created is about updating the value. So we can imagine that the car is driving by the city, and from time to time the sensor in the car will measure the speed and will publish that information to the context broker. And the updating of the speed is done using this operation. In this case, we are using the put verb. Put is the typical verb used to update things in REST on the URL identifying the attribute. So this URL is the one belonging to car1, which is the entities, and using the attrs speed. And in the payload, we provide the new value. We provide the type, float, and the value. We'll see that there is an operation to, if I want to update the value, just to the value and save this type, we can do that using another operation. But this will be the more complete. And again, we will get this answer from the server. That means it's a 200 code. That means that everything goes OK. So with that operation, we will update the value of a given attribute. Yeah, this is a remark that it can happen that you may have the same ID in different times. The entity identification, remember, that is the combination of type and ID. So you can have another type, for example, the type vehicles, and you can have car1 also in that. So in order to resolve that ambiguity, you need to add this parameter to the URL in order to identify that you are referring to a specific entity type. But if there is no ambiguity in your system, you can use just car1, this URL, and everything will work OK. OK, so this is the producer part. We have seen how to create and how to update context. So the other part is how can my application to consume that information. So this will be the operation to use. Is a get operation. This is the standard way of getting information in REST APIs, which is done executing the URL identifying the attributes. In this case, I'm not using any payload. It doesn't make sense. I mean, I'm asking the broker, so why include any payload? So, and the payload is in the response. In this case, what I get is a 200 OK code, and the response that the broker provides is the information that I want to retrieve. Is the speed of the car. So the type, the value, and this little part, which is empty, I will explain later, the one about metadata. So by the moment, ignore metadata. Okay, this is for the speed attribute, but what about of getting all the attributes? Because asking attribute by attribute could be very heavy for the client. So there is also one operation to get all the attributes. That's it. That's just to remove the speed of the URL. Get on this URL, you will get the list of attributes, all the attributes of the entity in the same response. Okay, this is the operation that I mentioned before about updating just the value. So I can, if I just want to specify that the speed has changed and the type of the attribute keep the same, I can use this operation, which has a simplified payload. In this case, I only need to put the new value. I don't need not even doing a JSON encoding for that. Just the value, and that will update the attribute value. It's another way of doing it. And also the opposite. I can, if I want to get only the value, I can do this operation, which is the get on the same URL that the one just before, and I will get only the payload, only the value, without any syntactical codification of it. Okay, more things. This is another example. This is an example of creating a room of an entity of a different time. It's an entity of type room, run number 1. The different of the new thing regarding the one that we have seen regarding car is that it shows how an entity with 2 attributes can be created, but you will see that the structure of the payload is the same. So the ID, the type, and the different attributes. Each attribute characterized by its initial value and its initial type. Okay. Well, this shows how to get the list of all the attributes of the entity. In this case, I'm getting all the attributes of room number 1, the temperature and the pressure. I'm getting those values. Well, this is more or less the same. I will go in a little quickly because I don't have too much time. Okay, this is interesting. Up to now, we have seen that when I get the the attributes of an entity, I get this structure using type, value, metadata, but many times I only interested in getting only the value. The type and the metadata doesn't matter, or I have already know them. In that case, I can use this parameter, options key value, in order to get only the values of the attributes. In this case, the response is a little different. In this case, what I get is just pressure and the value of pressure, and just temperature are the value of pressure. I don't have this JSON for each one of the attributes with the type and the metadata for them. So this can be a more convenient way of consuming information in some cases. Okay, this is another create an example. Nothing interesting, nothing new. Yes, this is interesting. This is this shows a feature of the get operation in Orion, that is the possibility of using filters for the information. See, if I want to get, for example, in this case, all the entities that has a temperature greater than a given value, then I will use that filter. So this filter is parameter is saying that, okay, give me all the entities in the key values mode that which temperature is greater than 27. This is just an example. They are filter for range, they are filter for equality, and you can combine different filters, filters for different attributes. I have another slide with a summary of that. If I have time, I will show you. Okay, well, the response is the entities that match that filter. Okay, this is another sample. This is a range filter. This give me all the entities which pressure is between 715 and 725. And well, the broker will respond according to the question. Okay, move ahead. Okay. Up to now, to summarize, we have seen how to create entity, how to update entity, or more than entities, context information, how to create context information, how to update context information, how to retrieve context information in a synchronous way. I mean, the application do the query and get the result. And finally, we will show you how to retrieve information in an asynchronous way. That is, how to create subscription in Context Broker, and how Context Broker will send notifications according to the structure. The idea is as follows. You have Context Broker. We have an application that use the subscribe operation. That operation will create a subscription. And then Context Broker will send notification to the receiver according to the subscriptions parameter. Let's see how it works using an example. This is the operation that a client will use to create a subscription. The operation uses this URL. This is the URL that identifies the subscription, and we do a push operation to create a subscription. The payload of the subscription contains the following information. First, it includes a subject. The subject is which entities, or which, in a more general sense, which context information is covered by this subscription. I will specify, in this case, an entity. So in this case, I'm subscribing to the entity room 1, which type room. We can use pattern then. I mean, we don't need. We can subscribe to a whole type of entities instead of individual cases. But in this case, for demonstration, we are subscribing just to one entity, the one which ID is RAM number 1. We have a condition. Condition means under which circumstances the notification will be sent. In this case, the condition includes an attributes parameter. That means whenever one of those attributes changes, then you have to send a notification. In this case, whenever temperature changes, then Orion has to send a notification. This could be more complicated. They also accept filters and geospatial areas, and well, the condition could be more complex, but the basic one is send me notification when some attributes or one attribute in this list changes. Okay, so this is a kind of description of the trigger of the notification. And finally, well, almost finally, we have the notification part. The notification part specifies how the notification has to be construed, where the notification has to be sent. It's information about the notification. It's describing the notification. It describes the endpoint. This is very important. This is the place to which Orion will send notification. It's a URL. So at the end, Orion will send a REST operation on that endpoint. The default method is POST, although it can be customized. And this attributes parameter, which is different of this one, is the attribute that has to be included in that notification. You have the option to include all the attributes of the entity in the notification, but maybe your endpoint is interested only in a subset of that. In that case, you can include the subset of those attributes in this parameter. It used to happen, as in this example, that the attributes that trigger the notification are the ones that are used for the notification. But it's not necessary in that way. This one and this one are independent. Finally, you have a parameter which is the expiration. You can have subscription that expire after some time has passed. So you can specify a date, and when that date passed, then the subscription will no be longer active. You can also have permanent subscription. I mean, this parameter is optional, so if you it doesn't include it, your subscription will stay forever. Okay, so your client will send that operation. The result of that operation is, in a normal case, is a 200 code with a reference to that subscription. That reference is the one that you need to use if you want to check the subscription, delete the subscription, or whatever. And in that moment, the subscription is there at content broker, and the content broker will look for it and monitor change in order to send notification when the condition occurs. For example, in this case, the subscription was about temperature. So if the temperature changed, if the temperature in row number 1 passed from 25 to 19, then a notification will be sent. How this notification looks like? The notification is the standard way, the standard format is this one. I say standard because Context Broker allows you to customize your notification. I mean, you can even send notifications that are not encoded in JSON. You can use text on ever XML, but this is another history. But for the standard format is this. The standard format, is used a post in the URL that you use for if you remember, the URL parameter in the notification area. And the payload of the notification, which is the interesting stuff for the receiver, is the place in which the receiver will get the information, includes a reference to the subscription. This is the idea of the subscription, that the endpoint may use or not to correlate the origin of the notification, and an element called data, which includes the information regarding the context you have requested. So in this case, you will get the format is pretty similar. Well, no, pretty similar. No, it's the same that they use in response to synchronous query. So you have the ID of the entity, the type, and a list of attributes, a list of case. Each one identifies an attribute, which value are the value, the type, and this mysterious field called metadata for each one of those entities. So if the temperature has dropped to 19, then your notification will include that value. Okay? So this is, this is an operation that can be used to check the status of a notification. As a client, you can check the status of your subscription, and you can get interested information. Apart from the information that you are specified to create the subscription, I mean the subject and so on, condition, etc., you can have information of the runtime of the subscription. For example, you can get the value of, you can get the information about how many subscriptions has been sent, or when was the last time a subscription was sent, or when was the last successful or failure notification. So, well, there are different aspects or different information that can help to know how your subscription is performing. Okay, well, this is only an example. The full description is in the specification. Okay, more things. This is up to now the basic stuff. I mean, with that information, you are now able to build context-based application on FIWARE, because you have now the basic knowledge or the basic primitive for those applications: create, update, and get in two different ways, in a synchronous way and in a asynchronous way. Apart from that, another interesting functionality are the batch operation. Most of the API is RESTful, but RESTful has some limitation. For example, in RESTful, you cannot actuate, or well, it's not easy to actuate easily in a set of resources. So, for example, if you want to create 20 entities in just one operation, you cannot do that in regular REST. You will need to do the same create operation 10 or 20 times. So in order to cope with that limitation, we create the update, the batch operation, that are not RESTful, are a kind of RPC, but operate in a set of resources. Maybe the most significant one is the one used to create or to update many entities in a single operation. This use this URL. All the batch operations use this op prefix. This is the op update that what it does is to create a set of entities in one operation. This I'm just realizing that this example is very a bit dummy because it only creates one, but as you can see, this is an array. So you can put this one, and after this other, and you can create 10, 20 entities in just one operation. No, I was wrong. This is continuous. So okay, this is the first entity to be created, the room 3, and this is the second one, the room 4. So this operation is creating 2 entities in the same SOT. The response is, as usual, a 200 code. That means that the entity has been created correctly. So I think I'm running out of time, so I will try to finalize in a couple of slides. So this is the API up to now. So you are now prepared to create application using it, but how I can get Orion, how I can start to playing with it. Okay, one way of getting Orion, if maybe in some cases very convenient, is to download it in your desktop machine, in your laptop. We have a virtual machine for that. You can access to that virtual machine in that URL. That URL gives you a file of, I don't know, 1 GB or something that you can import using VirtualBox. So you can get that virtual machine, run it using those passwords, and in the virtual machine, it's Linux-based. You will get an Orion service up and running that can be used to test it and to see these things in a real way. Another alternative that is pretty extant nowadays is Docker. Do you know Docker? How many of you know Docker? Well, probably most people that Jason. Amazing. Okay. Docker is a lightweight, virtualization technology, and well, it's very easy to deploy things using Docker. So we have a Docker for Orion in Docker Hub, and if you do that commands to get the Docker from the Orion repository and run it, you will get an environment with Orion and MongoDB. MongoDB, by the way, is the database used that Orion use. You will get also an Orion up and running in a couple of minutes. Okay. In addition, although it's more complete, is Orion with other pieces of FIWARE, but I think it's interesting because it shows how Orion is the core of a set of elements that interact with it, as Jose has explained in his talk. Is the demo application, the FIWARE tutorial application. So it's also Dockerized, so it's another way in which you can get Orion, which much more stuff with SIGNUP, IoT agents, I think, and well, all the security framework. This is self-contained. There is a README that explains how to play with it, and it's also, I recommend you it not only for your Orion, so in order also to see how Orion interacts with other enablers from FIWARE. Well, we are just ending, and we have seen only the top of the iceberg. I mean, we have seen the basic stuff for creating context information, updating, getting that, circulation notification, but Orion, this is only part of the functionality that Orion provides. There is more interesting functionality, there is more powerful functionality about pagination, geolocation, support from dates, filter. We have just seen some little sample of using filter, but the stuff is much more powerful. Delete attributes and metadata, for example, for specify automatically the last modification date of an attribute. That is very interesting. Also the ability of having attributes or metadata which value is a JSON object or a JSON vector. The metadata concept itself, I mean, attribute has metadata, and metadata are a kind of characterization of the attribute. So they are also in the model. So the model is not just entities and attributes, it's entities, attributes, and metadata, and the API allows also manipulate this information. Also, operation to browse types of entities. I mean, to get a list of the different types that Orion has. Custom notification. So as I mentioned before, how to have notifications that are in text or in XML that can be very useful to integrate with external system that has a specific syntax for the request. Multi-tenants. Orion supports multi-tenants. You can have different tenants. Each one is isolated in different databases. And ways of structuring information in different subservices. So this is also interesting stuff. So let me go. This is the presentation contains an introduction of the different aspects that I can now. Sorry, I can now go into that because I don't have more time. In fact, I think that I'm overpassing my slot. So, but this presentation will be available for you, so you can have a look after the talk. And yeah, this is the end. Well, just to give you some pointers, because this is not the only talk about context management and Orion. There are more stuff on that. In particular, well, all the agenda is interesting, okay, but within the agenda, I would like to highlight these ones. There is one presentation about the geospatial capabilities of Orion and how this information also can be persisted in Carto using Cygnus. And in this case, we will do a demo of how it works. So if you are interested in geospatial functionality, I will recommend you this talk. I think that the time is not correct, so check your agenda from the right time, but the day is correct, the day is tomorrow. Next, we also have a presentation about how to persist historic information. During my talk, I have mentioned that Orion only keeps a snapshot of the context of the system. So if you want to get an idea of the evolution of that information a long time, you will need another enablers, another stuff, and that presentation will give you the keys in order to implement this kind of systems and how it works. In addition, this is, well, again, it's a little advanced. It's mainly for people that already knows NGSI version 1. How many of you knows NGSI version 1? Oh, so probably 1, 2, 3, 4. Okay, this talk is about it's about the difference, how NGSI version 2 improve NGSI version 1. So you have NGSI version 1 application and want to evolve, something that I strongly recommend. This presentation will give you the keys to do that. And in addition, we'll provide, if you don't know about NGSI version 1 and you are new in this world, This can be interesting because you will see part of this advanced functionality that I mentioned in the ICVR slide. And finally, there is on Thursday there is a presentation about a context provider simulator that is a way of simulating a context producer for your application, and it's very powerful. It has different models to create entities and to update entities and context. And it can be very useful if you are playing with context management and you need something to fill your database, or you want to have some models and want to implement dynamics on those models using a simulation. So this is also very useful for developer during the testing or development implementation stage of your project. Those are some references that you can find online, which go deeper into this stuff. Probably the easy way is just use Google and look for Orion Context Broker. But well, we have different stuff. We have the specification on the standard. So this is the reference. We have this presentation, well, of a slight different presentation, but it's basically the same. The catalog page of Orion in the FIWARE catalogs, which provide also a set of pointers to get all the information. And well, if you need support, our official support channel is Stack Overflow, and so you can post your questions there using the FIWARE Orion tag. You also we also have a GitHub repository, so another way of getting support is also GitHub issues created in that repository. But well, for questions, this used to be the most convenient way. And that's all. Now it's time for questions. I think well, we can have some minutes for some questions. So any question for the audience? Yes. Hi.
What happens if it doesn't change from 1925, as pointed, but when we have data like 2 digits decimal, we have a slide changes, so I need to take notifications when 1 degree changes.
Yeah, I understand.
Scenario. I'm receiving data from a weather station or something like that, and I want to get notified to initiate the system only when I have significant changes.
Yeah, I understand your question. There are different approaches for that. One of those is in the origin. I mean, the producer can do some kind of filtering to ensure that no very little change progress to context broker. That's one solution. Another solution will be to use one parameter that can be used in subscription, which is throttling. Throttling is a kind of way, award period. So you can state that when you send a notification, you have to wait some time, for example, 1 second, until the next one is sent. So in this case, if the source is very noisy and it can change little, you will unless ensure that notifications are not received to very close. But it also may happen that in that particular second of word, the temperature changes from 20 to 25, so overpassing the threshold. So this system is not perfect. A perfect solution is not yet in place. We have this necessity has been identified before, and we have been talking about this kind of it. I mean, it will be to include one parameter in the subscription about a threshold or some kind of hysteresis solution that I mentioned. First, doing it at the source, or second, using throttling. Yes, it's a third option. That is a kind of filtering in the first one was filtering in origin.
Two systems are connected, but let's say I don't want to notify every second, in short time periods, but I want to do that first in Orion. That's why.
Yeah. Okay, so people from organization are telling me that we have no more time, but I will be around during the break, so you can do your question face to face. That is more friendly. So thank you very much.
Yep. So sorry to cut the question, but we're running out of time. We have the coffee break now. It would be a little bit shortened to overcome the latest chat, and well.
4, porque no, también hago.
Bueno, los 4. ¿Tienes el cacharro este? ¿Puedo avanzar? ¿Te importa?
Sí, mira, a ver.
¿Esta es la tuya?
A ver, sí. A ver, la de para atrás. Y luego
No has cambiado el estilo de la policía de las transparencias.
y luego ya no aparece o qué. Yo ya Sí, claro. Pero os llamo al principio a todos, ¿no? Sí. Vamos a hacer ahora de IoT industrial. Hombre, vamos a ver un poco cómo hemos empezado con Smart Cities, que es donde realmente hemos empezado a desarrollar cosas. Industria no lo hemos tocado mucho hasta ahora, o sea, está más para el plan futuro. Pero el modelo es el mismo, con lo cual te interesa ver cuál es el modelo, porque es lo mismo que queremos llevar en Smart Cities. Vale. So, are we all in place? Okay, let's get started. So this is the session for connecting the IoT to FIWARE. And first of all, I would like to invite the speakers here. So Daniel, can you come? Jill and Erno. Okay, so I think now we can get started. I will be giving the presentation on the introduction, right? So how we connect the IoT to FIWARE, a very brief and high-level overview. Then my colleague Daniel will introduce the IoT agents, which is the main piece that together with the NGSI brokers is able to push the information to the FIWARE. And then my colleague Erno from NEC will introduce the IoT broker, right? Which is a IoT-specific NGSI broker, right? And it extends the capabilities for the IoT context. And then at the end, so last but not least, Gilles Privat from Orange will introduce a solution of a NGSI broker for the IoT gateways, right? So his presentation will be focused more on the IoT edge. That is one of the points where we are evolving. So this is all. I would like the session to be quite interactive. So when you have questions, feel free to interrupt us and make questions, or you can wait till the end or grab us in the corridor if you feel shy. And let me go first with the introduction. So lately we hear a lot about the smart application areas, right? We hear about smart cities, which is municipalities trying to get IT technologies to deliver new services to the citizens and even to create new businesses. We hear the same now, or we start to hear the same for the smart agri-food sector with the smart agri-food concept, where the IT technologies want to develop services that help the producers in the agri-food environment to be more efficient or even to be able to deliver products in a different way. Then we have smart regions, which is a number of municipalities get together and then they try to deliver services similar to the smart cities, but to a wider region, right? Some number of municipalities together in the end. And then we have the very key topic of a smart industry, which is applying similar technologies, but in a different way to the Industry 4.0. All these technologies, all these areas of application are possible because we have some emerging technologies that are bringing a lot of changes. The first one is the Internet of Things, right, which is the subject for this session. And the Internet of Things allows us to put a lot of sensors and actuators on the field and then retrieve a lot of information, so perform monitoring activities in a different way and also to be able to control the processes in a much more efficient way. It brings also a lot of data to the ecosystem so that new businesses, new ideas, and new solutions may arise. Then we have the cloud infrastructure, which allows any provider to deliver in a very fast and efficient way new services from the cloud. You know this very well. We have the big data and analytics in general, that this is one area of application that is, or one technology that is growing quite fast. And finally, we have the mobile application ecosystem, because we shouldn't forget that in the end, we have in our pockets a computer, a very powerful computer, that is able to access these cloud services, etc. But with all these things, we are still missing some pieces. And one of the pieces that we are missing is brought by FIWARE, and it's the interoperability. So the $1 million question is when IoT interoperability or smart application areas interoperability will happen. And the answer to this is not very easy, because you can see in the image, but that was the purpose. You can see how many alliances and standardization bodies are working on this, right? And it's quite hard that interoperability will come out from all this mess. So our vision that started a couple of years ago is, our vision is to provide this interoperability at the context data level, right? In the end, IoT resources are data resources, right? So we can model the reality of IoT with entities. This has been quite well explained by my colleague Fermin before, so I will not extend on this. But from the IoT perspective, the main point is that we are providing exactly what developers and data scientists, for instance, would like to see from the IoT, because they are interested in the data, right? And maybe they are interested to push information, so they trigger actions and commands. But at that level, they are not that much interested in the device management, in the IoT-specific networks management, etc. There is a place for that for integrators, of course. But in the end, at the data level, which is the level that we believe the interoperability can be provided today, this is not the need. The need of the developers that we tried to satisfy from the very beginning was first to have a common language for all the data sources, being IoT or not, because when you are developing a new application or you are developing a solution for a vertical in a smart city, you are interested on the data source and the data that is providing in real time with access to the historics, etc. The developers are also interested on having a single REST API, single API in general, but it fits REST better because it's more simple and it's what they are used to nowadays. So they just want to query the data, subscribe to changes in the data, and trigger actions, right? And as you saw in the presentation of Fermin, this is very easily done from the API of the context broker. And you know that we are delivering open source solutions, and what the developers want in that area is that we use the same tools they are used to, the GitHub, read the docs for the documentation, etc. So this slide will appear many times in the event, I believe, because the core of FIWARE, and it's also the same way in the FIWARE IoT, is to gather all the data in a context data ecosystem, right? So in this case, you can model the users that live in a city, you can model street devices, you can model also the public transportation system, etc. And with this, you can infer the KPIs that the municipality is interested in, etc. And what is the difference in our approach and what was happening time ago? Previously, the smart asterisk or any smart application area was made of different silos, right? Or we call them verticals in the smart city arena. You had, for instance, a service for the garbage collection, monitoring, you have the water monitoring from the municipality, you have the energy saving and monitoring as well, and in each of them, you had several devices, if there were devices, right? Because sometimes it's not related to IoT, but we are considering IoT now. Then these devices are connected to the cloud normally or to some data service using some specific communication technology. And then you have some kind of intelligence to deliver a dashboard with the KPIs that are needed, or you have some data analytic techniques so you can infer conclusions and maybe send notifications to someone to control something, etc. And then you had this standalone solution for each one of the verticals that you were delivering to a city in this case, right? But it's the same for smart agri-food or smart industry, etc. The point here is that we were getting higher efficiency because in the end you are bringing automatization, right? So normally the common suppliers that were dealing with municipalities on these services, they got more technology, right? They were using new technologies, and then the services were more efficient and you could control more things. But this is not the main purpose that we are looking for, because that brings efficiency, but normally it's just that, efficiency. Maybe it's even for cutting jobs in the end, because you have to send the person less times to monitor the city systems or to monitor the garbage containers, etc. Our vision tries to deliver a growth engine in a local way for all these scenarios, right? For smart cities, for smart agri-food, etc. The point is that you can only do this if you lower the barriers to enter for new suppliers, right? I'm not talking only about the startups, but they are, because new ideas will come. Why? Because in the end, you bring more efficiency, because you can share the same communication technology, the same connectivity for several devices, from different verticals. But the most important, with an IoT agent, you will adapt the specific IoT technology they are using or the specific IoT protocol they are using, and you will bring all this information into the common and standardized NGSI data ecosystem, right? So then, for developers, for third parties willing to deliver a service, or for data scientists, there is a common place to get all the data or to retrieve all the data in a standard way, right? Sometimes this data will be open data, right? We have many cities that day by day, they are willing to deliver more open data to the citizens. We have experiences with the smart cities where the mayor of the city sometimes tell us, all right, so I was able to put all the data, all the open data that I have in the city, for instance, in a website. And yes, the citizens were interested in the beginning, they were accessing this, but in the end, when the hype is over, nobody else is accessing there, right? Because you have to provide the data, not raw data or processed data to the citizens, you have to provide this to developers of applications, you have to provide this to data scientists, etc. And the only way to do this in an efficient manner is to have a common standard for that. And this is the main idea. In the next presentation, my colleague will explain how you can connect, for instance, devices with a specific IoT agent. He will go into the details of the API. But we have different flavors of IoT agents. We don't believe that, at least at this point, will appear an emerging technology for all, right? There will be very different solutions because in IoT, there are many different conditions. There are constrained devices, for instance. There are places where the mobile connectivity is not available, so you have to use other kind of networks. There are new IoT networks arising like LoRa, like Sigfox, etc., and they are changing continuously as well. But we believe that in the end, you will be able to adapt all these specifics into the data ecosystem, and you will evolve with them. This is not fixed, right? This is a living creature, and we are creating new IoT agents, and moreover, we provide a library so that you can create your own IoT agent, and this can be done in few days for developers. So in this part, we have higher efficiency because you also share the cloud infrastructure for many verticals, but also, in the end, you have the possibility to have cross-vertical ideas. This is the main point. And this is how the most used IoT stack looks like, because you know that in FIWARE you have different generic enablers, and you can use them optionally, so you don't need to get all them to build up your solution. But this is what we've seen that is more useful for the IoT integrators, developers, etc. You have the IoT agents that translate the specifics into NGSI. Then you have a broker. Normally, we've seen the context broker or ION context broker for these kind of use cases. Then for the historics, you use different databases connected with the Cygnus. For instance, CCAN for open data, Hadoop, or the short-term historics component that we deliver as well. And then you have the intermediation of a PEP proxy, right, for security reasons. So only the people or the developers that may access a specific subservice of a service may access these resources, or maybe they can perform certain operations but not others, maybe read but not write, etc., or not create. I wrote a very easy decision tree on the IoT agents, right? Daniel is presenting later the ones that we have so far. The first question is, you can develop code for your devices or not. Maybe you can't because the devices are so constrained that you cannot do that, or maybe it's a closed solution, or maybe you're just lazy. If you can't code a specific protocol and it's not supported by us, then you have to get the Node.js library that we provide and develop your own IoT agent. But this is really a very easy task for experienced developers. If you can code for your devices, or you support some of the protocols that we are using, we try to support the standard protocols, then you need to ask yourself if you are using constrained networks, constrained devices, etc. If you are doing so, then you should be using very light protocols based on UDP, like OMA, lightweight M2M, etc. In lightweight M2M, there is also some device management, but we have implemented so far only the way to send data. And if your devices are not that much constrained, then you can use JSON to communicate with your devices, or a text-based protocol that we call Ultralight 2.0. And you have different alternatives for the transport. You have HTTP transport, or you have MQTT transport. And this is the ongoing work that we have in our plans. The first thing is the evolution of the IoT agents, so include new functionalities. So our team, for instance, is working in data transformations, so you can adapt the data model of the devices to the data model that you want to have at the top in the broker. We are developing, or we are considering new protocols, but we will do as they become de facto standards, right? Or maybe they are provided by the community. And we will have a look to the IoT management, but we didn't so far because the landscape is quite complex, right? So this is normally addressed by IoT integrators, but of course the first consideration we will make is to implement the management functionalities of Lightweight M2M and to maybe to be compatible with the management systems of some IoT networks, like the mobile M2M network. Then we will go from a cloud centralized model, like the one I presented, to a more distributed model, because for many scenarios, they are requesting that the decisions are taken first at the gateway levels, and then maybe the data is pushed upwards to the cloud. So we are starting to test how the IoT agents that we have today may run in the gateways. There is a version of the context broker, a lightweight version that runs even in a Raspberry Pi that has been developed by Orange, and Jill will introduce that. And we have even a CEP that is working for that, a complex event processing. So you have all the intelligence in the gateway, although later you send the data up to the cloud. Then we are working in the data models. In the Smart Cities, the OASC Alliance that was mentioned this morning, and the Smart Agri-Food, we have the Internet of Farm and Food project, that is the flagship project on smart agriculture, that is starting in January next year, right? Both DG Connect and DG Agri are funding this project, so we expect a lot of visibility on the results and the data models that we will create here. Then we are investigating the federation and more specific IoT NGSI brokers, like the one that NEC will describe later. And we are working also in the market dynamization, because you need devices to support the standards that we are considering in FIWARE. It's not very difficult because we are using common standards from the market, but we are involving the device makers to providing their websites, the instructions to configure their devices so that they can very easily be plugged into FIWARE. We call this the FIWARE IoT Ready program. If you look for this in Google, you will find the page, and we have up to 15 device vendors, and we expect to grow quite fast soon. This is all from my side, and now it's you may have the questions now, or you can wait for later on. Maybe it's better at the end, but if there is something, all right.
I will try to give you a very quick and brief introduction about what the IoT agents are and how they fit in the FIWARE architecture. First of all, the main purpose of the IoT agents is to serve as a kind of translation layer between the devices in the southbound that are typically constrained systems that use specific protocols like CoAP, MQTT, and so on, and the core of our platform that is the NGSI context broker. First of all, when a project involves extracting information or acting with a device, it will interact in two ways with our IoT agents. First of all, before starting sending information or starting sending commands to the devices, all the projects that are using those devices must register them in the IoT agents. In order to do so, the IoT agents provide a northbound API for the registration both of groups of devices and of singular devices. And in the process of that registration, we will see that the customers or the companies that are creating those projects can set the properties of those groups of devices, like security properties, the API key or trust tokens used for accessing the data, as well as mapping the information from the devices to the representation that information will have in the NGSI context broker. First of all, when we design the IoT agents, we have several principles in mind. We wanted them to have to be modular and stateless, so we can change the way we deploy the IoT agents. We wanted to be able to have different architectures, horizontal scalability, and so on, deployment flexibility. And also we wanted to ease the creation of the custom IoT, custom IoT agents. If you have devices that don't use a particular protocol that is already implemented in our IoT agents, we offer a library in Node.js that will easily give you the ability to connect your protocol, protocol for your specific devices to the platform, while giving you all the abilities, the default abilities that all IoT agents have, like registration of devices, registration of groups of devices, model transformations, and so on. I will show you now some examples of how a group of devices is provisioned, of how a device is provisioned in the platform. The northbound APIs of the IoT agents are mostly based on REST designed architecture, and you will have a different resource for the groups of devices and for the devices themselves. This payload you see on the right is the payload to create a very basic group of devices. You can see in the payload that the only two important things that are specified are an API key that all the groups of devices must define in order to assign each device to that group, and the type and the protocol that device will be using. Whenever the device is going to send information, it will indicate two pieces of information to the IoT agents in order for the IoT agent to know how to map the information it's coming. One of that pieces of information is the API key of the group of devices the devices belong to, and the other one is the device ID you will give in the registration of the device itself. As you can see, when you register a device ID, you can define some information about how the device ID data is going to be mapped to the entity data in the context broker. Here, we only see the entity type information, but you can also specify entity type, entity name, and a lot of different ways of specifying the attributes of the entity. In the attributes section, you will specify the mapping between the names of the attributes in the protocol, the southbound protocol data payload, and the name of the attribute that specific data will be mapped to in the NGSI entity. In this case, we have a southbound attribute called lum that will be mapped to an NGSI attribute called luminance. We can also define the type of the attribute in the NGSI entity. Along with the definition of this basic information, the IoT agents provide the capabilities of data model transformation in order to let you combine some of the information coming from the southbound protocols into different higher level entity attributes. And it will also let you map different the same same data to different different entities, not only the default device entity. One thing that I didn't mention before is that each device will be mapped. Typically, each device will be mapped to a single device entity in the NGSI context broker. But that default behavior can be overridden with the provisioning of the device. Here I will show you a small example of how information, once the device is provisioned in the platform, how the device can send information to the IoT agents. In this example, we will be using the Ultralight 2.0 HTTP IoT agent. The same, most of the IoT agents offer not only offer a single protocol, a single southbound protocol, but different transport for that protocol. In this case, we use HTTP, but the exact same payload could be used with MQTT or other protocols in order to get exactly the same output in the NGSI part. As you can see, with Ultralight 2.0, the only thing you have to do in order to report some information, in this case, is some information about parking spots, the occupancy of parking spots, and a luminance sensor. The only thing you have to do is to send a simple post to the southbound endpoint of the IoT agent, indicating two pieces of data, as I told you before. The API key you defined in the group of devices, and the device ID you defined in the provisioning of the device. That data will be mapped to the NGSI device, to NGSI entity representing the device in the context broker. The retrieving and sending of commands is quite similar. In the case of the IoT agents provide different ways of interactions, and in the case of the commands, when you want to send a command to the device, you can either define an endpoint for the device in order for the IoT agent to send the command directly to that endpoint. In that case, the IoT agent will post the payload you have below directly to the endpoint you have defined, or you can define the commands as pull commands. And in that case, the IoT agent will return the information of all the pending commands for each measure the device has reported to the IoT agents. So the device can retrieve the commands whenever it's available. For example, if a device is sleeping for a very long time, it will retrieve in the next time it will report a measure. It would retrieve the pending commands that have been generated all the time where it was asleep. In the case of the polling commands, that piece of code is a return for that specific case of a pull command. And well, all of this, all the information about the IoT agents, about the IoT agents in general, can be found in the FIWARE catalog. And you will find links to all the IoT agents of the different protocols, as well as the IoT agent manager and so on. There is a special repository that is the one of the IoT agent library. In that repository, you will find not only information about how to develop an IoT agent, but also a lot of general information about how the IoT agents work, and the definition of the northbound APIs of the IoT agent, those that let you create groups and provision particular devices. And so with this I finish, and I give the turn to Gil.
So we are waiting for the right presentation to come up. Here it is. And I'd like to present you the IoT broker component within the FIWARE protocol stack. And the first question you're probably going to ask is, oh, there's a context broker, and now there's an IoT broker. What is this, and what is the difference between two things? And the good news is, first of all, on one hand, it's the same thing, because they're talking the same APIs, and you can use it more or less interchangeable at different things. On the other hand, it's completely different, because the IoT broker is targeting towards IoT scenarios where you are not looking like in a data-centric view where all the data is pushed into a cloud and the cloud is going to handle that and you're not caring about. And for this relatively simple data-centric, cloud-centric model, the Orion broker was developed. For the IoT broker, we are looking now at more complex scenarios where we are looking into IoT networks, we are looking into the requirements of what IoT is needing and how in the future smart cities are using IoT networks for their purposes. And I'd like to introduce a few advanced systems once this is going to work, which is not. Was this going forward? Yeah? Okay. Maybe somebody at the back can press for me. Can you press for the next slide? Or solve this thing here. Oh, just turning it around. Thank you. So easy. So you see, technology needs to be made for the people who are using it. We want to take a look at some of the advanced features of the IT broker, especially how we are incorporating semantic knowledge into the brokering process. We are going to look into federation aspects here and into scalability. And at the end, I would like to look into some real-world scenarios which we're currently looking in, and into FogFlow, which is our edge processing extensions to FIWARE. So first of all, to give you a picture where we are, the IT broker, as you see, is part of the IT backend. It is reporting data to the Orion context broker. It's using the same API, and that's what I said. You can use it interchangeable, because wherever an IT agent is reporting into the IT broker, he can also report into the Orion broker, because the APIs are the same and can be interchangeable used. Now the IT broker is adding additional command flows through the system and additional features which we are going to tell you in a minute about here. So that's where the IT broker is allocated in the overall architecture of the FIWARE chapter. And later on, when Jill is presenting, he's going to explain you how we are handling edge processing on the edge and complex event processing here. So very fast, the IT broker is collecting from the devices, from the gateway, from other sources of the IT system, data, is providing and mapping that into what we call the thing level. So instead of having a single sensor with its ID and its very technical information, we like to be able to talk about the things, the car, the houses, the computer. And the IT broker is doing this mapping by moving into the NGSI API plus using the respective data model. And we are executing then the information queries on behalf of the application. And you've seen in the Orion broker, the information query was a simple query towards the locally stored last value of the information. In the same way, we can do an access to local stored information in a cache. You have, for example, a plug-and-play component which you can add to the broker for a big data store, where you can keep the complete history of data, but you can also forward the request to the devices and the gateways. And that allows you to have what we call the silent Internet of Things, where not every sensor is all the time sending the data up to the cloud, but we can forward and query the sensor at the right time. And of course, we can mix and merge the different models, because in some times it makes sense to send all the data up to the cloud. Sometimes it's better to keep the data low because you only need it from time to time. IT broker is implementing this different semantics of the execution and allows you to do that. In addition to that, we have advanced discovery operation. Coming to that, what I mean with advanced in this later chapter. And we are collecting and aggregating in the broker already information. We are not leaving that to the apps. Or let's put it this way. Some things we are doing in the broker, some things the applications are doing because it's domain-specific knowledge. Now, skipping that because of the timing, you see that we have the subscribe notify and the thing level information, which is representing by having different naming schemes, by having typing of the information objects and adding the context information, which we all think is very important, and then having discovery and resolution operation to find the devices here. and some advanced features which you can find up in our documentation on association and entity compositions. I like to talk about this protocol stack of the future, which we think is happening. We think that, you have seen that in Carlos' presentation, there are thousands and thousands of different IoT development systems. And all of them are trying to make an abstraction of the hardware and trying to have a protocol for delivering the data. And some of them make sense because they're directly integrated into Windows, or they are on some other areas and they cover an industrial automation system, but they're all very different. There's an emerging international standard called 1M2M, which is happening, which is on one hand standardizing a lot of the interfaces towards a low-level implementation. On the other one, give you a very precise service, and it's basically shipping a data container from A to B. But you don't know what's inside of the data container, and that's exactly where OMA and GSI, the IoT broker, the Orient context broker is coming in, where the information is getting out of pure data, which is shipped from one side to the other, to data, to information that is understood and can be used. And this is where the IoT broker and the Orient broker is coming in, where we can also handle the big data aspect of it, and we get information into knowledge and do processing on site. And we have in the upcoming years new projects which are looking into these architectures. On one hand, an EU-Korea call and an EU-Japan call, where we're looking into these kind of city platforms as a service. And we have the large-scale pilot on autonomous driving, which is using this architecture, 1M2M. Looking at the advanced features of the IT broker, first, knowledge processing, how we are factoring knowledge into the data model, the federation aspect, and the scalability aspect. Knowledge. Basically, in the IT world, one of the key characters of the future is that we want to have an open system where thousands of sensors from very different vendors, from very different users should be integrated into the system. And it's very important to understand them, to understand the context. And that's where we need to have knowledge. And that knowledge needs to be represented and made operational, and we should be able to query it. That's why we introduced recently the IT knowledge server into the picture. And that is then collaborating with the IT broker in having advanced features for lookup and improving the way what users can do. In addition to that, we can store static and dynamic knowledge about sensors and their relationship to other objects inside of the triple store in the knowledge server. Let me go directly to what we are doing. We have predefined queries which is helping the IoT broker to find objects. As an example, we have subtyping relationship introduced, which allows you to, for example, say you have a temperature sensor and a movement sensor and an air quality sensor, but they're all sensors. And you would like to model this kind of subtyping relationship, and then in your queries, you want to be able to use that subtyping relationship. Being it, I'm searching for all kinds of sensors, being it, I'm searching for all kinds of cars, or whether I'm searching for a Mercedes car or a BMW, I don't care. I want to have that modeled and executed as part of the queries. And that's what the knowledge server is adding. And we have some advanced functions, like we can add new queries into the knowledge server, we can have Sparkle queries and others. To give you a view on how that is looking like, I have an IoT broker. He is asked to execute a query like give me all sensors from Tokyo. He is making a query, what sensors could there be? So I'm trying to understand what are sensors. I'm looking into a cache, but the cache is telling me, no, I don't know which other sensors or which other sensor types might be there. Then I'm looking up in our internal architecture into a small database, which is basically storing what kind of query do you need to execute to find the subtypes of the type sensor. I will get that returned. That is then sent to an Apache Gina Fuseki triple store, where all the information is stored about the sensors and the typing information here. There it is executed. I get returned that my system knows about temperature sensors, about noise sensors, and about light sensors, which I can then return, and then my query execution will not only find the temperature sensors, but will find all these kind of sensors. And you can imagine that this simple example can be extended to much more complex things. So that's where additional function is added to the broker part here. And of course, we are storing that in the cache, and that's how the broker is using it. He is now, as you see here, checking for the different types, the generic sensor as well as specific sensors here in a single query, and you can easily extend the database and add your new knowledge to it. Yeah. So that was the knowledge server, and one example how the knowledge server is being used in the system to answer to some of the requests. The next thing is about brokering, meaning we are looking into federation of system. As an example, in our commercial systems, we are using FIWARE in some of our commercial installations. We are surprisingly having a lot of new services being developed in New Zealand. We have some smart waste and other commercial operating services in Europe, but we have a range of new services in New Zealand, and we are still operating our cloud from the Madrid data center, and we are more and more getting the information from down there. But we are understanding that, though the international lines are working quite well, we still need to deal with this federation aspect. So basically, we're looking into substructuring our IT platform into a central data hub and then local data hubs, and using again NGSI for combining these systems together, like you're being shown here, so that you have applications which can access the information, which then can access the information in the local system. And of course, as shown here, we can not only have this hierarchical structure, as you have seen, but we can mesh up the different IT brokers together and then have applications and each of the different brokers accessing the local view on the system, as well as doing international or worldwide queries here. So that at the end of the day, we are being able to provide a federated system which can provide you with information from all around the world with these federated structures here. And you see inside of the protocol implementation, we have some sub-features for efficiency detection, for efficiency in other areas here. Scalability, basically, we're expecting that the number of devices is going to increase, but as well the number of applications and the number of queries which we're doing toward this. So basically what we need to do is we need to scale the IT broker. Very simplified speaking, we have created status brokers which are externalizing its state and which can be replicated, and where we can ask the queries to each of the broker is then executing the queries, including, for example, the federation. And whenever you need more horsepower, you can add more brokers to it, and then the queries will be executed here. That's what we're needing to deal with, the amount of devices increasing as well as the amount of clients increasing here. Now looking at some of the scenarios where all of these pieces are coming together. One is we're looking at a smart city magnifier, which is an application which would enable users to really look into a city and find out is there a critical situation, what are the current statuses there, and very fast integrate the situation together. We've showcased that at the Etsy M2M workshop 2 weeks ago. And basically you see it's collecting data from many different cities, from many different sensors, not all coming from the same vendors. In order to deal with the heterogeneity of this data, we are running the system through what we call the morphing mediation gateway, a gateway which we can dynamically extend with functionality. That's research in the device IoT project. We're getting data from Korea, from Paris in France, from Santander in Spain, from Guildford in the UK. Very soon we are going to get data from Wellington City and other areas. And all of these cities are unified into a single ontology, pushed through the semantic gateways to have a unified data model, and then ending up again in NGSI, on which we are then writing the dashboard application, which can utilize the data for visualizing and enabling you to monitor the cities and detect critical situations here. And last, so that's some of the visualization and some of the way how this is working. And the last point where we're extending FIWARE in the IT chapter is to look into the edge. And basically what we can do is on the edge side, which is the lower part of this slide, we're having Docker containers where we can push dynamic code towards. We have a topology master which can monitor that edge parts and which can send functionality down there. As part of this Docker container, you can have local aggregation function, complex event processing, like Jill is going to introduce very soon, mediation to local systems, and all of them can then locally communicate between the edge nodes and send information up into the cloud-centric or the IoT broker side here. And that system, which we're going to call FogFlow, is going to be a system in which IoT developers can specify on a very high level the topology of analytic processes they want to have, and the system is analyzing this topology and then dynamically installing that into the edge devices as well as into the cloud devices based on profiling of the topologies and understanding how much data is sent between the different analytic components here. And basically that's ending my talk. I might take one or two questions if there's immediate one, otherwise there's a generic question and answer session later on. Not? Then.
Hello, I'm Gilles Privat from Orange, and I'm the leader of the IoT chapter. So I will be presenting something which may appear to go against the grain of mainstream platform architecture, because we implicitly assume that all platforms that we are interested in are hosted in the cloud in some way or another. And obviously this is what we have been doing in FIWARE with what we call the backend part of FIWARE, but this is also what is being done in lower level and more specialized platforms that are used as data providers for FIWARE, and these platforms also are actually hosted in the cloud. And you may end up with an architecture where actually before collecting data from sensors, you might have like 3 round trips to the cloud before the final application can get hold of the data. So what we are interested in is an architecture where it would be possible to avoid these round trips to the cloud and to operate close to the data, close to the field. And that's what we call the edge part of the FIWARE platform. And I will explain how this can work and how this answers a need for what some applications need to operate on. So this diagram shows an overall view of an instance of a FIWARE architecture that we could implement for smart city applications. And this is obviously intended to show that the edge part of the FIWARE platform is a very limited part of the overall platform. Most of the FIWARE components are still obviously hosted in the cloud, in what we call the backend part of FIWARE. And we have only this very limited and very specialized part of the platform that operates on the edge. And this is again shown on a special example intended for smart cities, but I will try to explain what is the reason and how we can actually achieve it. So the idea behind this is that we are again going against the grain of what most, especially big data applications tend to do, is they collect data and they send it to the cloud, to cloud-based repositories, whatever this data comprises, and it may comprise meaningless or noisy or totally useless data. And most applications still collect this data without filtering it in the first place. And the idea, what we try to do in this edge part of FIWARE is try to achieve some ecological data processing, filtering, cleansing data before sending it mindlessly to the cloud, as most applications again would tend to do. And this in some way or another makes up for the imbalance between the upward flow of data, which looks like a garden hose, and the downward flow of data, which looks more like a syringe, where this is the present situation for most IoT applications. So the idea, again, for what we are trying to do at the edge level is to pre-process the data and to do some kind of processing that is akin to something that has been done for quite a long time in a field of signal processing called sensor fusion. And this is more or less a very well arcane domain of of signal processing, because it's exclusively dedicated numeric processing that you have to implement in a specialized configuration for the type of data configuration you are interested in. But what we are trying to do is do it in a more generic way, using, as I will explain, complex event processing. Complex event processing doesn't make it possible to do the kind of sophisticated data fusion that you would like to do in, for example, robotics, or the kind of perceptual data fusion that you might be interested in some applications. But again, the trade-off is that you have something that is easy to program and easy to implement, and ideally that could be reconfigured automatically. And this is, again, the aim of what we want to achieve when we implement these applications through a platform instead of implementing them in a dedicated way. Another requirement that I want to insist on is not only the avoidance of wasteful management of data that I mentioned before, but addressing the needs of those applications that require bounded return trip times between the field devices, between the plant, what the specialist of automatic control calls the plant, the system that you actually, the physical system that you actually control, and some applications require controlling these systems with very strict latency requirements. And this is what most industrial control applications used to do with a fully dedicated implementation, and the people who implemented these kinds of systems didn't ask even the question whether there could be a problem with unbounded or non-deterministic latency, because it was implemented again in a fully vertically integrated fashion. And we still have to deal with these industrial kind of cyber-physical system applications, even though we are trying to implement them in a way that is completely different from the way they have traditionally been implemented. Again, they have been implemented as dedicated, vertically integrated applications, and we are trying to implement them through a platform like FIWARE. I won't go into the details of what we should be doing for achieving this, but we should be able to mirror the state of the physical systems that we want to control in the platform itself, to make sure that the action that we will be taking on these systems is the appropriate one, because to change the state of a physical system, you have to know the current state it is in. Because the action you will take to get to a new state depends on the current state of the system. So this is obviously something well known in automatic control. This is the very basis of the whole domain of automatic control, but people have been tending to discount this when they are using regular IoT platforms like FIWARE. So the idea behind this is that we have to implement part of the platform again in the edge domain, where this is the part that is represented here, where we can guarantee deterministic bounded return trip times between the field, between the lower part, which are the physical systems that we want to control, and the platform, which is implemented not only the representation of the entities that we control, but also the applications themselves. Because the idea in this is that the applications themselves would have to be hosted with the platform itself to ensure this deterministic latency and return trip. So I think I'm showing the same picture that José Manuel showed in his introduction this morning. So this is an example of a system that you might want to control in a smart city through the same kind of abstractions that we are using in FIWARE. But again, in this case, if you want to ensure that you have deterministic bounded latencies between the platform and the field devices, the actuators in this case, you would have to host it in the edge domain. Obviously, well, a lighting management application is not that latency critical, but there are other applications which are much more critical than this, and for which you definitely would need to guarantee this. So the kind of processing that we do is achieved with this enabler called, the implementation of the enabler is called Cepheus. The enabler itself is called IDEC. So the name is for IoT Data Edge Consolidation. And the way it works is, as was mentioned before, there is a very lightweight broker, which is, this is, I understand this may be partially confusing for most people, because we have now 3 brokers. We have the main Orion broker, which is a backend broker. We have the IoT broker that Erno described before. And we have this very, very lightweight broker that is meant to operate on the backend. Of course, this is the main difference with the 2 previous ones, which were meant to operate in the backend. This one, sorry, I said this one operates in the edge, not in the backend. And that's the main difference. And it's the routing. It performs some kind of routing between the data that originates from the devices. So we might also have IoT agents that would be hosted in the edge to guarantee again this kind of bounded latencies, and the processing would be performed also in the back end. So the idea behind this is that you can do all the latency critical pre-processing, the platform kind of data mediation, and the application itself on the back end. And just to finish with a more concrete view of what these kind of edge platforms could be, they span a very broad spectrum between what on the high-end side could be what we as telecom operator call next generation points of presence. These are well, very powerful servers that are located, as their name indicates, close to the local area networks, but they are not gateways in the traditional sense. And we could also, of course, use traditional home gateways or building gateways as hosts for these kinds of platforms. And previously in FIWARE, this, what we call now the edge domain, used to be called the gateway domain. And the reason we changed the name is precisely this, that it need not be hosted on traditional gateway in the network sense. It can be hosted in a very broad range of devices. And on the low end side of the spectrum, we could even host these kinds of platforms on Raspberry Pis or embedded servers. And we actually did test the Cepheus enabler that I described before on such low-end device. So, and of course, the idea behind this is that ultimately the whole joint backend plus edge platform should be managed transparently as what is called now a fog platform. We are not yet there, and we still have to manage the distribution between the edge and the cloud in a fixed and dedicated way, but we are moving towards the direction where this could be managed more or less transparently. So we would have a distributed platform, in a sense different from the one Erno mentioned, but distributed between backend and edge parts of the platform. So this concludes my talk.
Questions? Come on, don't be shy. There's one question over there.
So, from what we've heard, can you tell us how much is available now, as opposed to what's on the roadmap for the future? Knowledge server, in terms of the Cepheus, is all that available now for us to use, or is it coming down the track?
So the knowledge server is on the GitHub, so you can use it.
Great.
today is not my day of dealing with technology. So you probably hear me better now. The IT knowledge server is on the GitHub. You can use it. I think the scaling aspect is also on the GitHub, so the new version of the IT broker is scaling up. And the federation aspect, to my understanding, is also on the GitHub. The edge side processing, as well as the semantic mediation and morphing mediation gateway, is part of ongoing research projects which are not yet publishing into the GitHub.
Yes. Regarding the roadmap that you mentioned, the work we've been doing so far is more to work in this cloud centralized model, right? Because this is like the very first thing you need to have. But once this is made and we see that there are enough part of the ecosystem, the FIWARE ecosystem, startups, etc., using this model, I think now is the time to go onwards. And although we've been working internally in the project for these edge distributed solutions, still we have not pushed this strongly to the community, right? But we expect the community to start to ask for these solutions where you want to deal with extended functionalities at the edge, as Erno was mentioning, and you want also decisions to be made also at the edge. So then you would like to go for a lightweight broker, etc. So the idea always in FIWARE is that you have the generic enablers, right? And you select exactly what you need. You can go from the keep it simple and stupid scenario that we presented at the beginning that should be sufficient for most of the applications today. But when you dig into IoT and you want to do something complex, then you need these edge solutions. And then we have to manage ourselves, and this will be seen in the meetings of the IoT chapter that I invite you to come in the forthcoming days here, how we will build up this roadmap. Because as this is an open community, the roadmap is under discussion, right? And everybody can express their opinion or their requirements, etc.
These were both a functional test and a stress test with a load that was, well, not with billions of sensors, but, well, I can't tell you a figure, but an order of magnitude of number of sensors that's realistic with regard to the applications we are targeting. Yeah, as I said, the whole thing should operate in real time, and it's meant to not add additional delays on the whole chain between the field devices and the application.
I can add to that. As I've explained to you in our fog flow area, we are using Docker container to encapsulate analytic functions. And we're also putting on the front end these analytic functions into Raspberry Pis. And running 5, 6, 7 Docker container Raspberry Pi, it's a matter of what is inside of the container, which is generating the load. It's not the overhead of the virtualization technique. Yes, it's adding a bit of overhead to it, but it's mainly, if you do complex event processing over a long time window, the processing overhead is much bigger, and that's determining how much the Raspberry Pi can handle.
Okay, more questions, or we can close? All right, so see you in the corridor and in the next IoT chapter sessions. So feel free to ask anything that you want to know. Goodbye, thanks.
You want to present ourselves?
Yes.
Everybody's leaving.
Yes. Okay, so let's move to the next talk. My name is Álvaro Alonso. I'm here with Cyril Langerville. We are part of the security chapter in FIWARE. Today with us are also Pascal Bison and also our colleagues Federico Fernandez and Joaquín Salvachua. We are all of us part of this FIWARE security chapter. So during these days, if you need help or you want to discuss anything about this, about security in FIWARE, you can of course talk with any of us. Okay. So let's start with this talk. This time, Cyril and me will present this part of this track, and what we want to explain you is how to manage identity in FIWARE. Okay, how to manage authorization and authentication in FIWARE ecosystem, and to understand what exactly identity means in FIWARE, we also like to start with an example that probably all of you already knows, okay? And I would like to ask you how many of you has a Gmail account here in the room? Okay, yes, probably a lot of a lot of you, okay? And how many of you has a I don't know, Hangouts account? Not all of you. And a Google Drive account? Yeah, okay, probably what you have to know is that if you have a Gmail account, that means that you have a Google account, and that means that you already, you also have a Hangouts account, a Google Drive account, and an account for using every service that Google is providing you, okay? So you have a single account, Google account, and even if you if you don't explicitly know that you also have an account of all these other services, you actually have it, okay? So you have a single account, and with that single account, you are able to access every service in the Google ecosystem, okay? And this is more or less what we want to provide with FIWARE, okay? We want to provide, yes, it seems all of us have the same problem here. Okay. This is the thing we want to offer also with FIWARE, okay, with FIWARE account. We want to provide a single entry point in identity in order to allow you to access every service in FIWARE, okay? But not only every service already available in FIWARE, but also every service you want to deploy. You want to design, you want to develop, and you want to deploy, okay? So we provide a single identity entry to use every services in FIWARE Lab, but also every generic enablers we provide in FIWARE, but also we want to offer you the possibility of adding this identity service to your own service. So if you want to design a service, an application, and you want to allow FIWARE users to securely access your service, you can also do it using the things we provide in security chapter, and we are going to explain you today, okay? So this is the aim of this talk, explain you how you can use these FIWARE services, but also how you can add to your services the possibility of using this service, okay, this identity in FIWARE. This is possible, this mechanism is possible thanks to a standard called OAuth 2. I don't know if you already know what is this protocol, but this is a standard that is used by all these services you can see in this slide, and of course it's used also by other services, a lot of services that we can consume today in the internet, okay? Probably you have experimented, right, when you enter I don't know, a service like, for instance, SlideShare or so on, they give you the possibility of logging using your Facebook account or your Twitter account, right? So when you click in this kind of buttons, you are using your Facebook or your Twitter credentials to OAuth 2.0, and this is the standard we also use in FIWARE to provide this possibility, okay? So several services. As I said before, this is possible thanks to OAuth 2 protocol, OAuth 2 standard. It's a mechanism that allows to provide applications the possibility of access restricted resources using. To understand this protocol, it's important to understand the different roles, the different type of users that, or the different type of entities that take part in these mechanisms, okay? We have a resource owner that is the entity that actually owns the resource, okay? In this example, following with this Facebook example, the resource owner external application is trying to access. We have the resource server, that is the server in which that data is stored. In this case, it's Facebook, okay? In the server where those data is physically stored, okay? Then we have a client that is the entity that is trying to access. So, for instance, when you are using a SlideShare, when you are logging in a SlideShare using your Facebook credentials, the client is the SlideShare server, okay? The entity that is accessing your data on behalf of you. And finally, we have the authorization server that, frequently is the same one that the resource server, and is the actor that is providing the access token. We will see now what are these tokens that are the keys that you can use to securely access these resources, okay? OAuth 2 provides the specification, provides different configurations, different possibilities that you can use when configuring it, okay? The first one is they call grants, okay? These different configurations are called grants, and we have 4 types of grants. The first one is the authorization code grant, in which here in this picture we can see the client, that is the server that is trying to access your resources on behalf of you. We have here the resource owner. In this case, is FIWARE, okay? Let's start talking about FIWARE. Let's forget Facebook. So it's the server that actually has your data, your resources, and then you have the client, okay, that usually using a web browser is trying to access these resources using this client server. So the flow between all these actors is the one you can see in this picture. When you enter in the web browser and click on this button, login with FIWARE account, the web browser is trying to access your resources through this web server, okay? And this server said, okay, this is a resource that is protected and that is owned by FIWARE server, okay? So I'm going to redirect you to the FIWARE server. So your web page now redirects you to the FIWARE, and now FIWARE is asking you to enter your account credentials, okay? Your login and your password. So this is important. You are not using your credentials here, so this server is not aware of your username and your password. You are always introducing your credentials here in this server. If the authentication succeeds, this server will redirect you again to this server with a response code that is a string that this server has to use to finally validate the flow with the server. And of course, this last request is sent from server to server, okay? So it is always secure. To perform this final request, this server needs to send the response code that it has received from FIWARE, but also the credentials of this service. So previously, you have to register this external service as an authorized application here in FIWARE Lab, okay? We will see later how to register this external application here in FIWARE, okay? And as you can see, the result of all these requests and responses is that this server has an access token. It's a token that represents the user that has logged in, and that can be used to access the protected resources of the user, okay? So it's easy, it's not a hard mechanism, but of course you have to implement it in your application. So imagine you are developing this server, you have to implement this flow in your code, okay, to perform this mechanism. This is the more frequently used grant, okay? So I have included here the details of the request you have to perform. The first one is the response to the request you have to send to the account server in order to redirect the user to it. Then you obtain the code in your server. This is the code you have to send with your service credential to the FIWARE account. So here you include in the next request the code you have received, and also here in the authorization header of the request, of the HTTP request, you include your service credentials, okay? The result of this flow is that you finally have, in case of FIWARE account, a JSON response with the access token and yes, the expiration time and another token to refresh it and so on, okay? So this is the set of requests you have to interchange with FIWARE Lab server in order to perform these mechanisms. But don't worry, because okay, yeah, I will say show you the link later. But don't worry about this mechanism, because there are many libraries available for different languages. So, for instance, if you are developing your server in Node.js or in Python and so on, you probably will have libraries that allows you to perform these mechanisms without having to know the low-level details. Okay. So, as I said before, this is the most common mechanism, the authorization code grant, but there are 3 more grants available in OAuth 2. This is the implicit grant mechanisms, in which you can see that the main difference is that here in the first request you send to the server, you already include the credentials of the user. Okay, so this user, using these mechanisms, has to introduce their login and password here in your server. Okay, so in this case, your web server knows the credentials of the user, so it's not so much secure that the previous one. Okay, but this is also a mechanism that is available in OAuth 2. The next one is the resource owner password credentials grant. in which the communication between the web browser and the FIWARE lab and the resource owner server is not needed, okay? And you send here directly the service credentials and the username and password credentials, okay? The result, as you can see, is always the access token that this server creates for this external application, and that represents the user. And finally, we have mechanisms that is there is a typo here. This is resource owner password credentials, and this is client credentials grant. Okay, this is a typo. And in this case, all the mechanisms is based on the credentials of the service. Okay, so here we don't use the credentials of the final user, let's say. We directly use the credentials of this service in order to perform the flow. But again, we have an access token, but in this case, the access token does not represent the final user. In this case, the access token represents the application, okay? But this is a flow that in some use cases can make sense also, okay? So, as I said before, you don't have to know all the details about several libraries for many languages that allows you to easily configure all this stuff in your server, in your application server. Okay, so don't worry about the details, but always it's better to know how the mechanisms work, because then we also in FIWARE provide a Node.js server application in which we of course use a Node.js library, one of these ones, and we provide a very simple example in which you can use in your FIWARE lab account that I have just explained. So you can download this code. We include also the Performa demo. But of course, if you want to see a live demo of this thing, you can search up later, and we can go to the security chapter room and perform you the demos or whatever. Okay, with demos and with extended documentation and so on. This is also available in FIWARE Academy. Okay, so this is the place in the FIWARE application, in the FIWARE account portal. You will obtain a client ID and a client secret that are the credentials you have to use inside your application to be able to perform all these requests. You probably will have a configuration file in which you can introduce directly these credentials. Also the URL of the authorization server, and probably with those basic configuration parameters, you will be able to perform all this stuff, okay? Again, if you want to know details about how to register applications and so on, you can check the documentation we provide, the courses we provide in the academic course, and of course, during these days, ask us anything using one of these 4 available grants. You will have an access token in your web application, in your server, and you will be able to request to FIWARE account server the protected information about the user that has logged in the platform. This is the request you have to perform, and including here the OAuth2 token, you will retrieve the protected information about the user. So finally, an access token represents the user. He's asked by the FIWARE account to give permission to access those resources, okay? Probably you also have seen before, when you log in with your wants to access your public information, your friends in Facebook, your public profile, and so on, okay? You have to authorize this application to access those things. So here in FIWARE account is the same thing, okay? But this is only done the first time you access the application. So Summarizing, you have an access token, and with this access token, you are able to access this protected information about the user. But this is not the only thing you can do with this access token, because, as I said before, in FIWARE, we use this identity service, this FIWARE account service, to allow the secure access to all the services we provide in FIWARE. Okay, so these services also include the generic enablers, the different generic enablers from different chapters we are offering in FIWARE. Okay, so using this access token, you can also send requests from your server, from your service application. You can perform requests to any of the available generic enablers we have available in the FIWARE Lab environment. Okay, so probably these generic enablers are compatible with FIWARE identity, and just including in your HTTP request, in your REST request, a header with the access token, you can be able to perform this request to the generic enablers, the available generic enablers. What is happening inside these generic enablers is that the generic enablers receive a request and checks the header of the request, in order to find if this is an authenticated request. If so, he gets the token from this header and try to validate it with the FIWARE account server. Okay, try to say, okay, I have received a request from a user with this access token in the header. This is a valid access token. This user is authenticated or is authorized to perform the action he's trying to perform. And then FIWARE account say okay or not okay. In this case, FIWARE account say, okay, yes, this user is authorized to perform this action. And then the generic enabler performs the action and responds with the requested information to the web application. Okay? So what is happening inside this generic enabler is that the developers of this generic enabler has introduced a component that we also provide from security chapter, and that is called PEP proxy, okay? Vilma generic enabler. This is a component that basically do the thing I have just explained. Gets a request, extracts or try to extract this access token from the headers, and perform a check with FIWARE account server in order to try to validate this request, okay? So what these generic enablers are doing inside is to simply install this FIWARE PEP proxy. So in the same way, they are using the PEP proxy to add security to the resources they are offering. You can do the same with your custom backend application. So when you design and deploy a backend application based on REST and on HTTP, you can include a PEP proxy on top on your REST API in order to secure the resources you want to secure. This way, you can decide to which users or to which groups of users you want to permit the access, and to which groups of users you want to deny the access to your services. Okay? Of course, these PEP proxies are going to perform some validation requests to FIWARE account servers. So these servers has to have the needed permissions to send this validation request. Okay, we are not allowing this request to every service in the internet. And in order to do so, you have to register the PEP proxy of your application, the PEP proxy associated to your application, also in FIWARE Lab account. And it is done here. In the same way, here in the information about your application, you retrieve your OAuth2 credential to configure the flow. You can also register a PEP proxy that will be able to validate these tokens with the FIWARE account portal, okay? So here you register a PEP proxy and you get a username and a password that you have to configure in the PEP proxy configuration file. This is also very simple. We provide an administrator guide that shows you how to configure these kind of things. And again, you can ask us or whatever if you have doubts about that, okay? So these mechanisms of securing a backend application using FIWARE proxy can be done in several levels of security, okay? And some of them implies another important generic enabler we offer in the security chapter. So my colleague Cyril is now going to explain you how these mechanisms work, including these three generic enablers of the security chapter, okay? So Cyril?
Thank you, Alvaro. So I will go into further details on what Alvaro just explained, but emphasizing the authorization part and the use of the PDP, the policy decision point generic enabler. So the FIWARE access control architecture, or the IAM architecture, identity and access management architecture, is quite flexible. So you have different ways of using it depending on your needs. So the most basic level is authentication. So in this context, you use the FIWARE access control architecture only for authenticating your end users, for identifying and authenticating your end users, and using, of course, the FIWARE account server or another instance of the FIWARE identity management generic enabler. Then you have level 2, which is basic authorization. So in level 2, you include level 1, so you need authentication first, and then you can do the authorization part. So authorization is a little bit more than authentication. You check that the user has the necessary permissions to do a specific action on the resource, on the target resource. So the action is typically the HTTP method, and the resource is the URL path and the web site or the REST service typically. And then the last level, the more advanced level, is level 3, advanced authorization. So the main difference with basic authorization is that in basic authorization, it's either identity-based access control, like you're just checking that the user has a specific ID to be able to do this permission, or role-based access control, so you're just checking the role of the user. And in advanced authorization, you're using a more generic kind of access control, which is attribute-based access control. So attribute-based access control is like a generalization of airbag. So instead of using only roles, user roles as the basis of your permission definition, you can use any kind of attribute, not only role, but organization, user organization. You can use attributes of the action, like the action ID or the action parameter. You can use attributes of the resource, like the resource classification, the sub-resource of the main resource ID, and so on. You can also use environment attributes, like the current time, or the location of whatever, or also the risk level, which can be used as an environment attribute, and so on. So getting into more details. So when you use just authentication, you use the PEP proxy that Alvaro presented already. And the PEP proxy will check the incoming access, the access token in the incoming request against the IDM, so the FIWARE account. The FIWARE account gives all the user information on all the information in the context of the token, of the access token, like is it valid, the expiration date of the token, and also user roles, user organizations, and user ID, of course. And other nice things like the user display name. So this can be useful if you want to customize the interface, the user interface. using the display name in your in the user GUI to display the name of the user. And this is, so in this kind of context, the authorization is not done by the PEP proxy. So in the PEP proxy, you can disable the authorization part just to do the authentication. This means that you have to do the authorization on your own, in your backend application, in your own way. So usually you may have your own authorization logic embedded in your application already, so you don't need the PEP proxy to do the authorization. But you have to know that you could do it as well with the PEP proxy, especially if you have a REST service, because it has a nicely defined API which is easy to protect with a reverse proxy. So the PEP proxy is a kind of a reverse proxy. So if we want to do basic authorization, this means that in the IDM you have defined some permissions. So you define the roles in the IDM portal. For each role, you define permissions that you assign to the roles. And then you assign the roles to your users. So each user should have been granted a specific role to be able to access your application. And this results in airbag policies pushed to the authorization PDP generic enabler. So this is the new enabler that we haven't talked about so far. And the IDM is actually, when you define the roles in the IDM, it is pushing the policies to the authorization PDP. So basic airbag policies. It's using a language called XACML, which is an Oasis standard for defining policies. And then on the PEP proxy part, so when a user tries to access the backend application, the PEP proxy will, of course, do the authentication like before. And then for the authorization, we'll send a XACML request to the authorization PDP. So a XACML request contains all the kinds of authorization attributes that you need to enforce the permissions. So in this case, it's the user role, the HTTP method that is requested, the path, the URL path, and the REST service. So this is the resource ID, basically. And then the authorization PDP replies with permit or deny. So if, according to the policies that you have defined, it is authorized to do this action, it replies permit, otherwise it replies deny. And then you get the access is forwarded by the PEP proxy to the backend application if it's permit. If it's deny, it's rejected with a specific HTTP code. So this is an example of editing the permissions for each role. So maybe you have used it already. You just define the name of the permission, the description, the verb, like the HTTP method, get, put, post, delete, and then the URL path. So the resource is the URL path. So I think you don't put the slash at the beginning. You just put the next part of the URL, and that's it. You save, and the policies is pushed to the authorization PDP. And then the advanced authorization. So if I go back here, you see at the bottom that you have advanced XACML rule. So when you use that, you can do advanced authorization. So you can specify, define more complex policies, which is attribute-based access control policies, that will be pushed to the authorization PDP as usual. So the rest of the flows are the same. The PEP proxy will do the authentication, then the authorization with the XACML request. But in the policies enforced in the authorization PDP, you will do more complex things. So the policies will be more complex, using attributes with more complex functions and things like that. And so you can do some more complex attribute-based access control policy there. So the flows are the same. It's only the evaluation of the policies in the authorization PDP generic enabler, which is a little bit more complex. And see here you can see an example of ZACML rule. So this is using the ZACML syntax, so it's a little bit more complex than the rest of the editor. And you see that you can use functions, you can use a combination of Boolean expressions and so on. And so you can do more complex stuff. And back to you, Albert.
Yes. Thank you. So the last thing we want to explain you in this talk is a feature that we have recently added to this security ecosystem, and that is the possibility of integrate identity with IoT part of FIWARE. Okay. Probably you have seen how IoT sensors work in FIWARE in the previous talk. Also, how context management is used in FIWARE, and the result, summarizing, is that we have sensors that are context producers or context consumers, and that will send requests to the context management generic enabler, the Orion Context Broker generic enabler, in order to publish and subscribe to information in this environment. Of course, if you want to add security to this stuff, we have to authenticate sensors. And of course, if we are talking about providing a single authentication point in FIWARE, authentication and authorization point in FIWARE, we have to include this sensor authentication there, okay? So what we have included is the possibility of allow sensors to create tokens to authenticate in FIWARE by themselves. So the final architecture is the one you can see in this slide, in which we have a context producer or consumer that is creating tokens by themselves, by itself in this FIWARE account portal. So the request that this sensor sends to the FIWARE context management generic enabler are authenticated in the same way the requests that a user sends to these backend services are also authenticated. Okay, so Context Broker inside Context Broker has also a PEP proxy inside that is getting the request sent by these context producer and consumers and validate them through with the FIWARE account server. Okay, so using this configuration, we allow sensors to perform this update and query actions in a secure way, also in following the standards of security in FIWARE. Okay. Of course, again, to be able to create these tokens in FIWARE account portal, these sensors has to be registered in FIWARE account, and we provide a new tool in the FIWARE account portal to allow this sensor registration. So in the same way, you can register a PEP proxy here in the application part of this portal. You can create as many IoT sensors as you want. So when you register a new sensor, you obtain a IoT sensor username and IoT sensor password. Okay. And using these credentials, you are able to create tokens for these sensors. Of course, you can reset the password. You can also delete the password. You can also use these credentials that are associated to my account, but I will remove them after the talk. So, okay, so basically we have all these things, all this stuff we have just presented is possible thanks to the 3 key generic enablers we have in the security chapter. are the identity management key rock generic enabler, the authorization PDP that is called Ausita Force, the main implementation is called Ausita Force, and finally the PEP proxy Vilma generic enabler, okay? Identity management is in charge of all this stuff, managing users, managing applications, managing organization, okay? Tomorrow we have hands-on explaining how you can install and configure your own instance of this generic enabler. It's very interesting. I recommend you to attend this talk. The authorization PDP is in charge of managing authorization in FIWARE, the PDP and the PAP part of the authorization. And finally, we have this proxy that is in charge of managing PEP, Police Enforcement Point of the authorization part, okay? We are going to give you some pointers for documentation, but always these days are a good moment to directly discuss with us anything you want to discuss. But basically, you have here information about the main or the more important parts of these generic enablers, okay? In case of the Keyrock generic enabler, you have to know also that inside this generic enabler, we have modifications of Horizon and Keystone projects of OpenStack. So this generic enabler is totally based on OpenStack. We are aligned with the community, and we are trying to contribute to the OpenStack community in every moment. So this is also a good point of this enabler. And we implement APIs like OAuth2, Keystone, and Scheme 2.0 in this generic enabler. You can find here the source code and also, of course, the documentation. I have also included here the link to this example that I commented you just before in order to test this OAuth2 part. And yeah, my recommendation is that you go to the catalog, because this is the main entry point in order to go to the installation guides, the user guides. Also, there you will find the image that we offer in the cloud portal in order to basically quickly deploy this component. Also pointers to Docker, Chef, and other mechanisms we have to easily deploy this enabler. And the same thing for PEP proxy generic enabler, okay? The source code, also the entry point for the documentation, and the global instance that in this case is not here, but yes, exists. So Cyril is now going to explain you the Ausita Force.
So you've seen the IDM, you see the PEP, so now the PDP. So PDP is policy decision point, as Alvaro said. So it's, well, actually to be accurate, it combines PDP and PAP, so policy administration point, because at some point, before you can enforce policies, you first need to manage the policies. So to be able to push the policies, to change the policy, and so on. In FIWARE, we choose to implement ABAC, attribute-based access control framework, because we feel that it is the future of access control, and it's already becoming a very important trend in access control. And as you can see at the top, Gartner said in 2013 that by 2020, the majority of enterprises will use ABAC as the dominant mechanism to protect critical assets, up from less than 5% today. So today is 2013. So now, obviously, we're a little bit more than that. So the FIWARE authorization PDP today is the only more or less standard specification for both PDP and PAP. In form of a REST API. So if you go to the OASIS consortium, you will see a REST profile for XACML, but it's only the PDP part, and it's very basic. You don't have the multi-tenancy aspect for a cloud application, for instance. And here in FIWARE, you have the multi-tenant, so you can have multiple domains, And each domain can have its own PDP and its own PAP. So you have some kind of logical isolation between the various PDP, PAP, and policies associated with them. And it's also the only open source 100% compliant with ZACML 3.0 with a REST API like this. So you have other implementation of ZACML, but not with a PAP and PDP REST API. And it's implemented the ZACML 3.0 standard and also extensions of ZACML that we call the ZACML profiles. So you have the REST profile, obviously, the RBAC profile. So you can still do RBAC with ABAC. So ABAC is more like a superset of RBAC. And you can also do multiple decision. So multiple decision is when you want to request, so to do multiple individual decision requests in the same ZACML request, so you can get multiple decisions in the same payload, so in the same ZACML response. So this is a very useful way to multiplex multiple access decision requests in the same payload. And also for performance reasons, so for performance optimizations, we implement another standard called Fast InfoSet, which is an ISO standard. So this basically improves the XML processing and the XML size, the size of the XML payload. And it's also extensible. You can plug in your own attribute providers. So attribute providers is when you want the PDP to get an extra attribute from an external source of attributes, an external attribute provider, like SQL database, an LDAP directory, or another REST service, like the context broker, for instance, and use that extra attribute to evaluate the policies. You can also use extra functions and so on. And the last point is that you can do PDP clustering. So again, for performance reason, you can have multiple PDP instances in the same cluster. And this way you can handle extra load for enforcing your policies. And that's it for the presentation of the PDP. So you can, of course, go to the catalog where you have all the information on the PDP. You have a FIWARE lab image if you want to instantiate PDP instance quickly, which is called Hotforce 5.4.1. So this is the last version of the PDP. You can also look at the API in the APRE format, so I would say a textual format. You can also get the source code of the Hotforce generic neighbor on GitHub. You also have the API specification in technical language, so which is called WADL, the Web Application Description Language. So WADL is very useful if you want to generate the client code automatically. So you have various tools, like in Java, for instance, you have tools to generate the client, the Java code from the WADL. It's like WSDL, but for REST services, and you can generate the code automatically. And then we distribute Hotforce in various formats. So we distribute it in a Debian package or Ubuntu package, and also for other Linux distributions, you can get the tarball, the tar.gzil, and we also provide the Docker container on the Docker Hub. So you have the link there, and we also provide a global instance. So it's just a public URL that you can use to test rapidly the Hotforce API. And finally, we provide the documentation on Read the Docs, and you can get the link from the catalog, of course. And that's it for the G's. Not working. Yeah. So thank you for your attention. And there will be a demo or presentation about the IDM tomorrow. in the morning, I think, or yeah, tomorrow morning. So if you want more details about the IDM, and if you want to have more demos, we can show them in the room that is dedicated to a security chapter if needed. So if you have any questions now, go ahead. Oh, we have one question there.
I'm not sure if I understand well. In your presentation, you talked about to us about the FIWARE account and the FIWARE lab, correct? So when I want to use another system as a production system, the Docker, that I implemented my series there, can I use the same mechanism as well? Can I do something different, or should I do something different?
Yes. You can use both options, let's say, both configurations. If you want that FIWARE Lab users are able to access directly your services, you can connect your environment directly to FIWARE Lab instance of Keyrock and Ausita Force. And then any FIWARE user that wants to authenticate can use their account, okay? But probably another possible scenario is that you want to have your own set of users in your environment. And then you can deploy your own instance of these components of FIWARE, of Keyrock, Ausita Force, and so on. And then users will have to register on your service instead of the FIWARE Lab. Yes, exactly. If you want to know how to install these components, I recommend you to attend our demonstration tomorrow. Okay. So, yes. Yeah, the only one that has the GUI is the Keyrock generic enabler. The other ones are backend components, so they don't have GUI.
Yes, for the PDP, you can use the IDM portal to edit the policies for basic use cases, like role-based policies. If you want more advanced XACML policies, if you want to use the full power of XACML, then you have to use your own REST client with XML. So, yeah. Yeah, another question?
Yes. Keyrock is based on both Keystone and Horizon. Okay, the backend part is based on Keystone, and the front-end part is based on Horizon. But what we have done is to introduce several extensions that we need to perform all the things we have just showed you. For instance, extensions to be compatible with Steam, to be compatible with Ausita Force, to be compatible with sensor registration, with OAuth 2. There are several things that we need here in FIWARE, in security, and are not included by default in Keystone. Okay. Again, tomorrow we will enter in details of all the things, all the extensions we have included from a vanilla Keystone implementation. Okay. Okay. So. If there are no more questions, we can go lunch. And thank you very much for your attention.
Thank you.
See you later.